So if you talk about software-defined networking, what is the use of software-defined networking, where it all began actually. So this software-defined networking is not, anything new that is there in modern day network. Software-defined networking is being used for like quite a lot of time. So typically, if I talk about types of network, we have some sort of enterprise network, we have some data center network, and we have some service provider network. Typically, like if I categorize a network in from the infrastructure point of view, we have some enterprise network, we have some data center network, and we have some service provider network. Now, the enterprise network typically focus on the enterprise infrastructure, such as a company that has some devices, some routers, some switches, some firewalls, some access points, some WLC, and they connect all together to create a network, which is what we are going to refer to as enterprise network. In the data center network, we have devices. We have different devices as compared to the enterprise network, because a data center is built around some sort of application. It is built around the application that this DC is going to serve. Data center is going to store a large amount of data in a centralized location. So data center network is built around the application that they serve. For example, a Facebook data center, a Google data center is going to build around the data that they can store on there. And different data centers can be there, different types of data centers network can be there. Data center network is designed in a different way than the enterprise network. And then the service provider network, typically such as ISPs that we have, Airtel, BSNL, and the other service provider network that we have, which are responsible to connect our different sites together by the means of some media and provide the connectivity end to end. So in all these network, we used to do the things manually. Like if I have to, for example, add a new site, add a new data center, add a new enterprise network, whatever we need to do the things manually. We need to install the devices in the infrastructure manually. We need to do the connections. We need to do the cabling. We need to run the protocols. We need to deploy the policies. Everything we were doing manually. All the tasks, everything we were doing manually from the configuration and design point of view. So what happened actually in the data center network, they started using some sort of automation. They started using this controller. They started using this controller called EPIC. Data center network is also called like ACI, application-centric infrastructure. So ACI, application-centric infrastructure, we have in the data center network. Data center network is generally built around some sort of application. Like, okay, what application this DC is going to serve? Around that application, application-centric infrastructure is built for the data center. And to manage that ACI infrastructure, we have this controller called EPIC, Application Policy Infrastructure Controller. So they had this controller called EPIC for our data center environment, so that they can manage the data center infrastructure in more like an automated way. They can just define their intent. They can just define their intent, and this piece of software, this device, if I say controller, this controller was supposed to convert that user intent, convert that administrator intent into the configurations, and it is going to push those configurations to the ACI infrastructure. So data center network, again, data center network is built around the application, hence the name application-centric infrastructure. And to manage this application-centric infrastructure, we used to have a controller called EPIC. EPIC stands for Application Policy Infrastructure Controller. This EPIC controller, EPIC Application Policy Infrastructure Controller, was the controller for the ACI infrastructure, application-centric infrastructure, where the user or the administrator will define its intent onto the controller, and the controller is going to push, controller is going to change the way this ACI fabric, this ACI network is going to behave. So this EPIC, this controller is going to basically configure the network in such a way, in a way that the user, that the administrator intended. And because of this controller-based networking in the data center, that managing the data center infrastructure became very easy. DC network became very easy to manage from the centralized controllers such as EPIC, Application Policy Infrastructure Controller. So in DC, in data center network, they had this controller called EPIC, Application Policy Infrastructure Controller. They thought if in the data center network, it is giving us so much benefit, we are using this controller, EPIC, Application Policy Infrastructure Controller, and it is giving us a lot of benefits in the data center network. Why don't we use the same in the enterprise? So what they did, they created a new product and they refer to as EPIC EM, EPIC Enterprise Module. EPIC and EPIC EM, these are two different products. These are two different things. EPIC is the controller for the data center, and EPIC EM, Application Policy Infrastructure Controller, EM, Enterprise Module. It was the controller for the enterprise network. For the enterprise network, if we have an enterprise network, where we have used some devices, routers, switches, firewalls, you can manage the devices from a centralized point using this EPIC EM controller, Application Policy Infrastructure Controller Enterprise Module. However, this EPIC EM controller could not gain a lot of popularity in the enterprise network. In the enterprise network, this EPIC EM actually was not that much successful as the EPIC controller was there in the data center infrastructure. So EPIC EM, like this product that Cisco used to offer, they discontinued this product. This product is no longer sold by Cisco. EPIC EM was the controller for the enterprise network. They also built other controllers such as, Cisco PI. PI stands for Prime Infrastructure. They also had this product called Prime Infrastructure for the enterprise network to manage the things from a centralized point. So they also had this thing called I-WAN. If you talk about from the WAN point of view, I-WAN, intelligent WAN, they used to call it. I-WAN, intelligent WAN. They used to have some I-WAN routers, and you can install those routers on your enterprise network, and you can manage those routers from a centralized point, which became the modern day SD-WAN concept. So they built different things. They built different controllers. They built different things for the enterprise network. But like, for example, this EPIC EM enterprise module, this EPIC enterprise module could not gain that much popularity in the enterprise network. And yet, hence, like they discontinued that product. They no longer sell this EPIC EM. Prime Infrastructure, however, was a very popular product that was being used in enterprise network. It was being used for a quite long time. I-WAN before the SD-WAN became very popular. After the acquisition of this Viptela, SD-WAN Viptela became very popular. Before that, they used to have this I-WAN. So EPIC was the controller for the DC network. EPIC EM was the controller for the enterprise network. They had the other controllers such as Prime Infrastructure. They had I-WAN technology for the WAN and all. They had different solutions to manage the things from a centralized, to have some sort of software defined, to have some sort of software controlling the entire infrastructure from a centralized point. That was the whole idea. Why should we configure everything ourselves? Why don't we give the intelligence to the software and they configure the things for us? We just need to define the intent onto that software, and those softwares should be able to do the configurations on the device. That was the idea. And it became very successful in the data center network. The EPIC controller is still being used in the data center network. ACI infrastructure is still being used in the data center network. But unfortunately, it was not the same for the enterprise network. So when Cisco acquired, the Viptela, I'm not sure exactly in 2016, 17, whenever they acquired these Viptela, Cisco SD-WAN Viptela started gaining a lot of popularity. Cisco SD-WAN Viptela started gaining actually a lot of popularity. And in 2021, it became a very popular product. Cisco SD-WAN Viptela became a very popular product for from a SD-WAN point of view. If you want to manage the things from if you want to manage the routers from a centralized point, go for the SD-WAN. Just to give you the idea, what is SD-WAN? SD-WAN actually allows us, software-defined wide area network allows us to manage all the campus edge routers from a centralized point. Like we have some routers that we have at the edge of our campus, at the edge of our company, and we can manage all these. We want to manage all these routers from a centralized point. We should go for this SD-WAN solution. SD-WAN solution, again, SD-WAN, Cisco software-defined access wide area network. SD-WAN uses a few controllers. It uses the concept of controllers to manage the managed routers from a centralized point. But the SD-WAN technology does not deal with the LAN part of it. SD-WAN technology does not deal with the LAN part of your campus area network, LAN part of your enterprise network. SD-WAN is just for the routers. You can have the routers connected directly to the WAN transport. You can have the router sitting behind some sort of firewall, and then that firewall goes towards the WAN transport, such as internet. You can have any type of deployment. This you will study in your SD-WAN content. No need to talk about that right here. But the sole purpose of the SD-WAN is to connect your enterprise managed routers to the transport and give us the capability to manage all these routers from a centralized point. It also adds a lot of security when we want to transmit the data from one location to another location. Why? Because as soon as one router gets aware of the other router, it is automatically going to build some sort of IPsec tunnel, and your entire data can now pass within the protection of the IPsec from one branch to another branch. A lot of advantages are there. SD-WAN can also be used to connect your enterprise network with cloud delivered branches. That there also you can use this SD-WAN. Basically, a lot of advantages are there. But again, SD-WAN focuses specifically on the managed routers. SD-WAN does not deal with the LAN side of the enterprise network. It does not deal with the LAN side of your campus area network. Right? SD-WAN we used to use, SD-WAN we are using in today's network as well. We are using this SD-WAN to manage all these managed routers from the centralized point. SD-WAN became very popular in 1920, like 2019, 2020, 21. It became very popular product for the campus, for the enterprise network actually. A lot of companies migrated their traditional network to this SD-WAN network. And right at that point, they thought, why don't we now, since the software-defined networking is becoming very popular, companies are going for the SD-WAN solution. Why don't we go for the, why don't we now introduce a controller that can manage the LAN infrastructure of your company as well? LAN side of infrastructure, why don't we introduce a controller that can manage the LAN infrastructure of your organization as well? And that is where they introduced this technology called SD access, or in short, SDA. So software-defined access, SDA gives us the ability, the capability to manage the LAN, local area network, LAN infrastructure from a centralized point. LAN switches that we have in our infrastructure, we can manage all those devices. We can build the network, we can design the fabric, define the rules and everything from a centralized point with the help of this SDA. And the controller that is used in the Cisco software-defined access is called DNA Center. Or in short, we call it DNAC, Digital Network Architecture Center, DNA Center. DNA Center is the controller that it is a hardware controller that you need to purchase and install in your infrastructure. For HA, they recommend that you have at least 3 of the DNA Center controller purchase and deploy them in some sort of cluster so that high availability can be ensured. So DNA Center controller that we have, or DNAC that we have here, DNAC is going to deal with the LAN side of the infrastructure. DNA Center controller we can use to manage the LAN devices, LAN switches that we have in our campus area network. And for the managed router, we have the technology such as SD-WAN. So SD-WAN technology is there for the WAN devices, and SD access technology or SDA technology is there for the LAN devices, specifically focusing on the switches that we have in our local area network. The controller that we use in the SDA is called the DNA center, and the controller sets that we use in the SD-WAN, they are called as vManage, vSmart, and vBond. We have three different controllers that we have in our SDA. One is called vManage, one is called vSmart, and one is called vBond. V stands for Viptela. So Viptela was the company who came up with the idea of this controller. So vManage, vSmart, vBond. V stands for Viptela here. Right? So SD-WAN controllers are going to deal with the WAN devices, and SD access controller DNS center is going to manage the LAN infrastructure of your organization, specifically focusing on the switches that we have in your local area, campus local area network. Now, one key thing to remember between the SD-WAN and SD access is that these controllers are virtual. There is no hardware appliance for the same. They are completely virtual. In fact, you can run these controllers in a simulated environment such as EVE-NG. We can do that. If you want to build a lab for the SD-WAN at your home, you can do that. You just need to have proper resources. You need to have proper resources, and you can build a SD-WAN lab at your home. Completely possible. These are all virtual. These controllers that we are talking about, vManage, vSmart, vBond, SD-WAN controllers are virtual. SD-WAN controllers that we have, these all are virtual. But the DNA center at the moment is hardware only. They have recently launched a software version of the DNA center that you can actually deploy, that you can run on virtual environment, you can run on the cloud environment such as AWS and all. People have deployed the DNA center on the cloud nowadays. But again, this is again, I would say, not going to be very, cost-effective solution. It's not going to be a very cost-effective solution. We'll see that when we talk about the size of the DNA center image that you need to run even on the cloud, you will get to know that. But the point is, DNA center was a hardware-only appliance that you need to purchase and install in your infrastructure. And nowadays, what you can do, you can also run it in the cloud, such as AWS and all. Right? You can do that. They are also planning to launch a scaled down version of the DNA center that you can run on your simulated environment, such as ESXi. If you have a few resources, some resources, if you have on your server, you can run that DNA center on your ESXi environment as well. That you can do. That is possible. That will be possible. They have not introduced anything regarding the same nowadays, but this will be possible sooner or later. Right. So one key thing that you should remember about this SD-WAN and SD access controller is that SD-WAN controllers are software, and SD-WAN is going to be SD access is going to be the hardware probably. However, they have launched this software versions of the same, but not sure when the scaled down version will come into the market, and you will be able to run it on the simulated environment in ESXi. At the moment, it's not there. You can still run it on the cloud if you want. You can run it on the cloud. You can run it on the cloud if you want, just in case. But it is going to consume a lot of resources. Anyway, and one more thing that this DNS center that we have, it is just a repurposed Epic EM. It is in the core, in the back, you will notice it is Epic EM. Ultimately, it is Epic EM. When we talk about the DNS center in detail, we will see that what they did actually, they took that Epic EM controller that they already had, and they just repurposed it, and they relaunched it with the name of, they added in this Epic EM, they added the assurance function. In the assurance function, they added the monitoring and everything, and they launched it with the name of DNS center. So actually, this DNS center is more or less, it is just repurposed Epic EM controller that we used to have in our enterprise network. So half of the DNS center is Epic EM, and then the Epic EM with the assurance functionality is what we call this DNS center DNAC appliance. Right? We'll talk more about that in detail later on. So the use of the Cisco software-defined access in a network is that we want to manage the things from a centralized controller. I want to design my network. I want to configure the devices. I want to do the monitoring. I want to do the troubleshooting from a centralized point. That I can do with the help of Cisco SDA. Cisco SDA is specifically going to focus on the LAN side of the campus area network. It is not going to focus on the WAN side of it. It is going to focus on the LAN side of it. For the WAN side of it, they have the SD-WAN, and we can connect. This is, for example, our enterprise network. Here we have the WAN edge routers, and here we have our switches. We have the capability to connect our SD-WAN with SD access. We have that capability as well. SD-WAN and SD access can be interconnected together as well. And your DNS center controller can also integrate with the vManage, so that from the centralized point, from the DNS center itself, you can also do some configuration changes on these SD-WAN routers. That can also be done. They offer that now. Nowadays, they offer that as well. That from the DNS center itself, you can integrate your SD-WAN controller vManage in the DNS center, and you can manage things from a centralized point of your LAN and WAN both as well. Right? So this integration is nowadays possible. It is possible nowadays to integrate our SD-WAN controller with the DNS center and manage the things from centralized point. Right. So why do we need software-defined networking? There are many challenges in today's network in managing the network because of manual configuration and fragmented tool offering. So there are many challenges today in managing the network because of manual configuration. Most of the networks today, they are being configured manually. And companies, they have different tools that they can use to manage their enterprise network. Since we have fragmented tools, like some companies are going to use some tools, some other companies are going to use some other tools. Since they are going to use different tool sets, because of that, you need to know about those tools if you want to manage the configurations from a centralized point. You want to manage the configurations in an automated fashion. So since we have manual configuration in a modern day network, and we have different tools, we have fragmented tools, we have different tools in different companies to manage the network, to configure the network. So one should be aware of those tools if they want to manage the infrastructure or they configure the infrastructure from one point. So that actually is going to impose a few challenges in the network. If you do the manual configurations, they are slow. You have to do the configurations one by one on the devices. They are error prone because a human is doing the configuration. So chances of errors are comparatively higher, and they are proving to be ineffective in a modern day network. With the growth of users and different devices types coming in the network, configuring user credentials and maintaining a consistent policy across the network for wired and wireless is more complex. With the growth of the number of users and different types of devices that can come into the net. Earlier, we used to have, for example, like desktop computer, laptop, but nowadays we have devices such as like tablets, PDAs. We have like IoT devices in the infrastructure as well, camera, sensor, and all. So with the growth of users and different types of devices in the network, configuring user credentials and maintaining the consistent policy across the network, both wired and wireless user, is a lot more. The pace at which the changes are being done, they exceed the human scale. The rate at which we are doing the changes in the network, it is going to exceed the human scale, and it is going to impose some network related challenges and some security related challenges. So when we want to operate our network, there are going to be certain challenges, and when we want to enforce the security in our network, there are going to be some challenges because of the manual configurations of the devices, because the rate at which the new devices are coming into the network, because of the rate at which we are doing the changes in the network is much more higher than the rate of the human that we have in the infrastructure. And more importantly, the changes that we are going to do, they are very slow, they are error prone, and they are proving to be ineffective in modern day growing network. In a modern day network, we have concepts of cloud. Earlier, we did not have that much cloud concept in our infrastructure. Nowadays, companies are deploying their infrastructure on the cloud. Companies are deploying their applications on the cloud. How are we supposed to connect our infrastructure to the cloud? How are we supposed to connect our hosted infrastructure that we have in our company? We have some hardware infrastructure. How are we supposed to connect this infrastructure to the cloud? We have different IoT devices nowadays. We have cameras, we have different sensors in the infrastructure. We have both wired and wireless type of user. People are doing work from home nowadays. How can we maintain the policies for those different types of devices and the users for both wired and wireless network? For the wired network, we are going to have a different set of policies. For the wireless network, we are going to have a different set of policy. So if the user connects itself via a wire, some policy has to be there. And if the user connects itself wirelessly in the network, then some policy has to be there. We want to control that this user can communicate with this and cannot communicate with that. And that has to be enforced for both wireless and wired communication. So it is going to be more complex if you are going to manage the policies for wired and wireless users indivisibly. So overall, the point is that there are different challenges that we are going to face from the network operations and the security operations point of view. We'll talk about a few of those challenges in a moment. So the bottom line is that the network of today do not address today's business need effectively. So we do not want to have a human doing the configurations in the network. We want some piece of software. We want some software that we can use to configure the network in more like an automated fashion. I want that there has to be some sort of software that we can use to manage the infrastructure from a centralized point. We'll talk about a few challenges that we get based on network operations and a few security related challenges that we have in a modern day network. And then we will talk about how the SD access is going to overcome those challenges. We'll talk about that in a moment. So there are some challenges that we face in a modern day network. For example, if we talk about operational challenges, let's talk about some network operational. If I categorize the challenges, we have the challenges regarding to a deployment, right? We have some challenges when we want to deploy our network. We have some challenges we want to operate that particular network. We have some challenges when we want to enforce the security in the network. We have some challenges we want to manage when we want to manage the network, right? We have some we have different types of challenges here. So for example, if you talk about deployment related challenges, let's say we have to deploy a new branch. let's say we have to deploy a new branch. In new branch, we have to deploy, let's say, for example, 6 to 7 switches, and we have to deploy a few like 2, let's say, for example, router. And on these 6, 7 switches, we have to do some configurations. We have to do like, for example, ether channel, link bundling. We want to do some sort of port security and all. We have to do some certain configurations on there. We have to do some certain configurations on these 6, 7 switches that we have. And we have to do some configurations on those routers, such as BGP configuration, such as policies and all we want to configure on these routers. Point is, we need to go on these, let's say, for example, 9 devices one by one, and we might need to do the configurations on those devices one by one as well. So first of all, we will take the console access of one device, then we will do all the configuration, then take the access of the other device, then take the access of the other device, and then so. A modern day network, they also use some configuration management tool, like configuration management tool. Modern day network, they can also use some configuration management tool, but again, those tools vary. Let's say, for example, organization to organization, and those tools have some limitations as well. For example, who has done the configuration changes, what configuration changes are done, all what lines, for example, in the configuration got changed and all those information might not be logged as we need actually. So no doubt to do these configurations on these 6, 7, 8, 10 devices, let's say, for example, 10 devices, we can use certain tools to do the configuration and manage the configuration as well. But those configuration management tools that we are going to use, they might be vendor specific. They might lack some features that we want in those configuration management tools. So deploying, for example, deploying a new device in the infrastructure is going to be time-consuming process. If you are familiar in your production environment, there is something called day 0, day 1, day 2 operations. Day 0, day 1, day 2 operations. In your production environment, you must have heard about these terms, day 0, day 1, and day 2 operations. Right? So deploying a new device in your network, or adding, let's say, for example, a new branch in your network is going to add a lot of administrative overhead, configuration overhead, configuration management overhead as well, right? So these challenges that you face are going to be labeled as, the deployment related challenges, all the challenges that you can face when we talk about deployment of the device. Then we have operational challenges, like, for example, some suddenly what happened. Let's say you have deployed your network, then suddenly what happened, 20 users have reported that they are not able to access the network services. 20 users have suddenly reported that they are not able to access the network resources. So what you need to do, you need to access those devices that you have deployed to perform some sort of troubleshooting. Like you need to access the switches, you need to access the router, and then you will use some troubleshooting commands. You will use some commands to find out the problem and to rectify the problems as well. We can also use some monitoring tools. We can use some monitoring tools. We can use protocols such as SNMP and all. We can use some monitoring tool where we might get alerts that, certain, for example, interface has gone down, a certain type of security violation has occurred. You might get some sort of, you might have some tools as well in your environment, and those tools might report you those different issues that the users are facing. But again, when it comes to T-shoot troubleshooting, you need to access those devices one by one, and you are going to run some troubleshooting commands. And after you run those troubleshooting commands, you are going to find out the problem, and you are going to correct the problem as well. So basically, once the network is deployed, you will also face some operational challenges. Users might report that, for example, they're not able to access the services, and you will use your troubleshooting skill to find out the problem and to correct the problem as well. Anyone else is facing any issues in the voice? Confirm once. Is there any problem in the voice? Anyone? Amit, Anand, Parpreet, Roshan. Okay, Umar. Okay, fine. Rejoin once. If anyone faces any issues in the audio, mostly it could be because of the browser. So try to rejoin once or try to change the browser. It will fix the problem. Sometimes that happens. So you have challenges in deploying the devices. You have challenges in the network operations as well. Once the network gets operational, you will face variety of operational challenges. We also have challenges regarding security. Let's say we have different departments in the user. We have a HR department, we have finance department, and I want to control that the HR department users cannot communicate with the finance department, right? So how we are going to enforce the security in our enterprise network? Also, I want to make sure that if any user tries to access the network, if any user connects their self onto the network, they must authenticate their self using some user ID and password, which has already been given to them. So like, the challenge is if I have, let's say, n number of departments in my organization, how are we going to, of course, the users are not only going to connect via wire, but they are also going to connect via wireless. So the question is how we are going to enforce the policy for both wired and wireless user in our infrastructure. You might have heard about the terms VLAN. You might have heard about the terms ACL. We can configure the VLANs, and by configuring the VLAN, we can more like segment. We can do some sort of segmentation, which means that our HR department is like, will not be able to communicate with the finance department because at the layer 2, we have put them in different VLANs. We can also configure access control list. We can also configure ACLs. In access control list, we can define that, okay, this network device can communicate with this network device, but this network device cannot communicate with this network device. Means like in the ACLs, in the access control list, we can define the entries that is going to control what two devices can communicate to each other and what not. Remember that we have standard ACL, we have extended ACL. In the standard ACL, we can match basic things. We can do very basic filtering based on the source IP of the packet. And the extended ACL is going to allow us to filter the traffic based on layer 2, layer 3, and some other layer 4 protocols, TCP, UDP protocols like HTTP, DNS as well. So point is, we can configure the ACL to enhance the security. We can configure, for example, like VLANs to add on some security in our enterprise network. But how many number of ACLs you will create? In one ACL, how many number of lines you will have? You might notice in your production environment, an access control list can have like maybe 500, 600, 700, 1,000, 2,000 lines. And suddenly what happened, like you have to remove an entry from the ACL and add a new entry in the ACL. That is going to be, again, a quite hectic task. Because if again, due to some human error, if due to some misconfiguration, you put incorrect entry in the access control list, your communication might get blocked. So in the traditional network, we can use like VLAN, we can use access control list, we can also use like a AAA authentication, authorization, and accounting server. We can use AAA servers to control that, okay, the user that has this user ID and password is going to be able to, it is allowed to join our network, it is allowed to access the network, but it will have only limited amount of access. We can control like authentication, authorization, and accounting with the help of some AAA server. AAA functionalities are nowadays handled by the ICE, or we can have some other third-party radius servers as well. Basically, to enforce the security, we have different products. We have different things to enforce the security in our infrastructure. We can configure things such as VLAN. We can configure things such as ACL. We can have AAA servers in our infrastructure to enforce the security in our network. We can create the policies, for example, in our security appliance such as ICE. We can create the policy for the wired user. We can create the policies for the wireless user. And based on the policy, the devices will be allowed to communicate or not communicate in the infrastructure. One has to understand the concept of ACL. One has to understand the concept of VLAN. One has to have at least some understanding of the security products such as ICE or other products such as firewall and all to enforce good security in the infrastructure. So there are going to be some security related products that you are going to have in your infrastructure. There are going to be some security related things such as VLAN ACLs in your infrastructure that you will be required to manage manually. Add the entries in the ACL manually. Create the VLANs manually. Delete the VLANs manually. Switch port trunk allowed VLAN. Remove. You forgot the remove keyword. And suddenly everyone is not able to access the services. Just one basic mistake and one very common mistake, and your entire network might go down. So we still have in a traditional network a few challenges that you face regarding like ensuring the security in our infrastructure. Management of wired and wireless user is going to be completely different. How you are going to manage the wireless users, how you are going to manage the wired user, policies for the wired user, policies for the wireless user, you might need to configure differently. You need to go on the wireless LAN controller to create a policy for the wireless user, and you might need to go on the switches to configure the policies on for the wired user. More importantly, the management is being done box by box. The management is being done box by box. Like, for example, in our infrastructure, we have like Cisco devices, as well as we have, let's say, for example, the HP devices, Juniper devices. We are going to take access. We might have a tool that is responsible, that can handle all the Cisco devices, but it cannot handle HP or Juniper devices. Management on the device is going to be done box by box. One has to understand interoperability between these devices, such as Cisco, HP, Juniper, and the other vendors as well. For example, you must have heard about the term span tree protocol. The way STP runs on the Cisco device is different than that it is going to run on, let's say, for example, HP devices. Remember that in Cisco devices, we have per VLAN spanning tree. On the HP devices, we have simple spanning tree. How the interoperability is going to be there in that case, one has to understand that part as well. So there is this vendor dependency. There is this vendor dependency, vendor lock-in issue, where if you want to do the management of a particular vendor device, the approach is going to be different than the other one. Right? How you are going to do the management of these HP, Juniper, and let's say, for example, Cisco devices. The management is going to be done box by box. A protocol might run differently on Cisco and non-Cisco vendor. So you must need to understand the interoperability between those devices as well. So in short, like we have different challenges. You can go ahead and you can find out more challenges in your model. We have not even talked about how are we going to connect our infrastructure to a cloud ready, like today's cloud world. Companies are going for things such as AWS. Companies are going for the things such as Azure Cloud, AWS, GCP. Different clouds are there in the market. How our infrastructure is going to connect to this modern day cloud network? We have some applications running on the cloud, right? Companies are actually deploying the infrastructure on the cloud. They are running, let's say, for example, some appliance on the cloud. How are we going to connect our infrastructure to that cloud delivered appliance? So in a modern day network, we have different challenges. We have challenges regarding to the network operations, where we need to perform the troubleshooting, where we need to ensure that the network is operational, up and running, and we also have the challenges regarding the security. So the overall bottom line of the network is that the network of today do not address today's business need efficiently. Network cannot respond quickly into evolving business needs if the changes need to be done manually. Such modifications take long time and they are prone to error. Effective network management can be exceptionally difficult to achieve in complex network with variety of users and devices requiring different access privileges. So there are different types of user. There are some users that are fixed at a particular location. There are some users that are roaming in the network. There are different types of devices, routers, switches, firewalls, IoT devices, and all. To ensure that the proper segmentation is there between those different types of devices and user, we need to configure different policies. And configuring those policies manually is again going to take time and might be prone to errors as well. Traditional IP-based network methods with firewall, VLAN, ACL do not scale, and they're not efficient in responding to real-time needs. We can enforce the security using firewall, using VLAN, using ACL, but this is not going to scale very well, and it is not going to be very efficient in responding to real-time needs. So as a report, as a simple report, like a ratio of operational expenses to capital expenses on the network operation, labor and tools is approximately 3:1. It means like companies are spending more money in the operational expenses as compared to the capital expenses. They are spending more money on network operation, labor and tools as compared to the infrastructure. 95% network changes in modern day network, they are done manually. 75% of operational expense on expenses are spent on changes and troubleshooting. 70% of the policy violations are occur due to like human error. This is just the stats. So in that case, like we have these like, for example, this is as per the report. These are the statistics. As per the reports, like a company spend approximately 3:1 in the operational challenges, dealing with the operational challenges, and like 95% changes are done manually, 70% security violations occur due to human error, 75% operational expenses are spent on the changes in troubleshooting. To deal with all these challenges, to deal with all these problems that we have because of manual configuration, because of different types of devices, users, to deal with all these challenges, they thought of implementing network automation. They thought of implementing the programmability in the network, hence the name software-defined network. To overcome these challenges, they decided to use software-defined approach to manage the network, where the engineer will configure its intent and software will automatically configure the devices based on the user, based on the admin intent. And there are three solutions. In the modern day network, there are three solutions. There are three different solutions. There are three different SDN and network programmability solutions available from Cisco. One is called Open Daylight Controller. Second is called Cisco EPIC application, Cisco ACI and Cisco EPIC. So there are three different software-defined networking and network programmability solutions available from Cisco. Others are there as well, but one is called Open Daylight Controller. Open Daylight Controller, where it uses the open standard model of the software-defined networking, and the controller that they named was OSC, Open SDN Controller. This was the controller that was built around the concept of network programmability earlier. However, this became obsolete. So nowadays you do not see these Open SDN controller based on this Open Daylight Controller. You don't see that nowadays. Then we have, for the data center network, we have ACI, Cisco Application Centric Infrastructure. And the controller that they use is called EPIC EM, Cisco EPIC Enterprise Module for the enterprise network. For the data center network, they had the controller called EPIC. And for the enterprise network, they have the controller called EPIC EM. So modern day network can be deployed around three major SDN solutions: Cisco SDN for the next gen wide area network, Cisco SD-Access for the campus area network, and Cisco EPIC for data center network based on ACI. Right. So in a modern day network, we have these three controllers. We have three SDN solution. One is Cisco SD-WAN, second one is SD-Access, and the third one is EPIC. basically Epic ACI, Cisco SD-WAN, software-defined wide area network, software-defined access, and Cisco Epic SD-WAN for the enterprise network, SD-WAN for the SD access for the campus area network, and Cisco Epic EM for the data center network. Even in the data center network, we can have at the edge, we can have our SD-WAN solution. Like this is our data center, and at the edge here, we have some routers that are responsible to connect our data center with the WAN transport such as internet. We can have here the SD-WAN routers as well. So SD-WAN is not specific to your campus area network. SD-WAN is just a general term that we can use in our data center and in our enterprise network both. In a data center network, we have two routers. In an enterprise network, we have one router. We can connect them with the help of the transport so that they can transfer the data in a secure fashion from the data center to, let's say, for example, headquarters. So Cisco SD-WAN is for like wide area network, SD access is for campus area network, and Epic is for data center network. This is the name of the controller, application policy infrastructure controller. In the Cisco SD access, we have the controller named as DNA Center, and the SD-WAN solution is built around vManage, vBond, and vSmart controller. What is the question?
सर क्वेश्चन ऐसा था, आपने कैरेक्टरिस्टिक्स में बोला था कि डीपली रूटेड एंड नेटवर्क ऑपरेटर्स एंड और एक नीचे लिखा हुआ था, तो हाँ, दिस चैलेंजेस आर डीपली रूटेड विद इन नेटवर्क एंड सिक्योरिटी ऑपरेशंस एज नोटेड बिलो. ये डीपली रूटेड क्या होता है सर?
Deeply rooted basically means the challenges that you face in the network. What are the challenges that you face in the traditional network that are built, that you will face whenever you create the network? So you will face some network operation challenges. You will face some security operation challenges that we have talked about.
सर वो नहीं ना जो अपन फोन में करते मतलब रूट करते वैसे वाला नहीं ना?
नहीं, that is not the thing. That is basically what challenges you will face in your network regarding operation, what challenges you will face regarding security in the network that we have discussed.
Thank you, sir.
So we have three things. We have SD-WAN, SD access, and Epic. SD-WAN, wide area network, SD access for campus area network, and Epic for the data center network. And we can deploy it end to end. We can have, for example, in our enterprise network, we have the SD access solution. We can connect our enterprise network with the data center with the help of the SD-WAN. So SD access for the local area network, SD-WAN for the wide area network, and the ACIE Epic for the data center network, and all of them can be connected so that we can have end-to-end software-defined network and end-to-end software-defined networking for the campus WAN and data center network using the controller. It looks like that. So in the enterprise network, we are going to use SD access. On the edge, we are going to use SD-WAN. On the data center, internally, we are going to use ACIE Epic. On the edge, we are going to use the SD-WAN router, and we can connect these together with the help of our SD-WAN technology. So we can connect our enterprise network with the ACIE data center with the help of the SD-WAN so that we can have end-to-end connectivity between our campus area network and the data center, and the traffic is sent from the device to the device in a secure fashion. So if you want to have the software-defined networking, end-to-end in your campus, in your network, you have to go with the SDA solution. You have to go with the ACIE Epic in the data center, and you have to go with the SD-WAN in the WAN part of it, so that you get an end-to-end SDN solution that can be managed via centralized controller such as DNA. That can be managed via centralized controller such as vManage, and that can be managed via centralized controller Epic. A dedicated GUI of the DNA center will be there. Dedicated GUI of the vManage will be there. A dedicated GUI of the Epic will be there. It will manage your local area network. It will manage all the WAN-S devices, and it will manage your ACIE data center from a centralized point. Right? So in your enterprise network, we will have a combination of both. We will have the combination of SD-WAN and SD access. We have software-defined wide area network, and we will have software-defined access. Our SDA is going to communicate with the SD-WAN to send the data in and out of your SDA network. So data can be received from the other branches in your SDA network, and data can be sent from the branches from the SDA branch towards the other site. So an end-to-end software-defined network solution will look something like this, where we have interconnected everything together with the help of this software-defined solution. So software-defined networking is the use of controller to manage your entire network. If we use software-defined approach to manage local area network of a campus, that is referred to as SD access. If we use software-defined approach to manage the wide area network of the campus, it is referred to as SD-WAN. And if we use the software-defined approach to manage the ACI data center, that will be done with the help of EPIC, Application Policy Infrastructure Controller. For the end-to-end software-defined networking, we can opt for all these three options, and we can connect our branches with the data center and headquarter and the other. We can also have legacy branches. This is our legacy branch. Here we don't have SD-WAN or SDA. I can connect it with the help of just regular MPLS or internet transport with the data center and the SD access as well. That is also possible. It's not like if you have opted for software-defined networking, you have to go for software-defined networking everywhere. It's not like that. We can also have the communication between traditional and SD-WAN, SDA, and ACI infrastructure. We are not going to talk about ACI, of course. We will talk in our content, we'll talk about SDA part of this SDN solution. SD-WAN part of the SDN solution is covered in the SD-WAN classes, and the data center ACI EPIC, when we cover the data center, then you will talk about the ACI EPIC. So from these three solutions that we have in our software-defined networking, we are going to focus on SD access, building the campus area network around the DNA center. Any doubt, anyone so far, let me know. Any question, anyone? Now we will talk about how the SD access is going to deal with those different challenges that we have talked about. How the SD access is going to deal with those security challenges, those management challenges and everything. Now we will talk about that. What is this SDA solution? How the SDA software-defined access is going to deal with all those challenges. Before that, any question, anyone? Let me know. Any doubts, anyone so far? Any question? All good then? Okay. So now you do one thing. Search DCloud Cisco. Okay. Just go to DCloud here. Log in with your credential right here. Log in with your credential. Let me log in quickly. If you don't have a Cisco ID, create one and then log in. Once you have logged in to the DCloud, just wait. Yes, it is completely free. Yes, you don't need to even hold any certification for the same. You can just log into the DCloud. Right, and it will, once you log in, it should show you something like, where is the main page? Yes. Once you log in, it will show you something like that. Right, once you log in, it will show you something like that. Now, just click on this catalog here. Click on the catalog. And right here, content products, content categories, solutions, and everything. Right? Just content product, filter DCloud, content catalog. You can click on instant demo. here. You can also schedule a lab here. You can also schedule a lab here. No need to worry about. So filter DCloud and instant demo. Now, either you can scroll down, all right? And once you are scrolling down, you will see, just wait, you will see Cisco SD-WAN, Cisco software-defined wide area network, version 20.9 with cloud integration. So if you want to explore, for example, if you want to explore things about SD-WAN, right? You want to see how the SD-WAN controller looks like. Just click on this view button here. It will open a new page, right? Here, you can directly log in. Here, you can just log in to the one of the cloud delivered SD-WAN controller. What is the user ID and password? Click on this related document here. You can click on this in the relate, or you can just do one thing. Just click on here. Click on this Cisco Secure SD-WAN 20.9 Cloud Integration Instant Demo. Click on that, and it will open a page where you will have the user ID and password. Scroll down here, resources, integration guide. Wait, it will show you the document here. Once you click on that, scroll down, scroll down, scroll down. This is the topology that you have to remember, that this solution is built on this topology. And if you scroll down, scroll down, scroll down, this is the user ID and password. Demo 1234. So you have to log in with the user ID and password here. Just put the user ID and password, demo 1234, and click on login button, and it will open the SD-WAN control. It is cloud delivered SD-WAN. You have no you have no control on configuration part of it, just the view level of access, read-only access, if I say. And this solution is built on this topology, right? So you can just click on that, and it will show you the graphical user interface of the controller that we have in our SD-WAN solution, right? And you can explore things about the SD-WAN. When you study SD-WAN, you will discuss about, you will know all about this. Just to give you the idea, this is our vManage network management station of the SD-WAN, where we can manage everything from a centralized point. We can manage the devices. We can manage different types of different IPsec tunnels that got formed. We can manage the security. We can manage the segmentation using the VPN. We can check the logs, and we can see how our SD-WAN is connected to the cloud. Everything you can manage from this centralized dashboard, right? And from here, you can also not only do monitoring, but we can also do the configuration of the devices, certificates. You can design the network, create the template, policies, security. Basically, how can you connect your infrastructure to the cloud? Every option regarding the configuration that you have on the WAN edge router, you can get it here. We have different tools to do the SSH, right from here to any device in the network. We can see the tag cases that we have opened as well. We can go to the maintenance. We can upgrade the software images and everything. We can do everything from here. We can manage the users who can log into this device. Local user database we can create on here. We have some different other workflows as well. We can check the statistics as well from here. As the WAN analytics, we can use that as well to check the statistics of our network, right? Anyway, so this is all about the SD-WAN. This is SD-WAN. This is all about the SD-WAN that you need to know. Now, similar to this, just scroll down here. Similar to this, just scroll down here. You will also have your DNA center. Either you can scroll down or you can just search at the top. You can just search at the top. Here, right here. No need to search, but you could have searched it as well. So Cisco DNS Center Automation and Assurance version 2.3.3.4 instant demo, right? You can just click on that. You can just click on view button. It will open the DNS Center graphical user interface, and you will log in to that DNS Center graphical user interface using the credential demo guide. Just go to the demo guide, and from here, you will have the credentials, the passwords, and everything. Getting started here on the top. Getting started. The user ID password is same, demo 1234 and exclamation mark, right? You just need to log in. I've already saved it. And this will open the graphical user interface of DNS Center hardware appliance that we have. DNS Center hardware appliance that we have. And we can explore things from it. Now, the good thing about this is that we can not only have the read only, but we can also configure quite a lot of things right here in the DCloud. For example, if you go here, design, we can create new designs. We can create the sites and everything. Policies, we can create the policy. We can do the device provisioning. We can discover the device, check the inventory, create the VM, sites, transits, everything. Assurance means give us the visibility. Assurance means give us the visibility of the network. That thing we can check it as well. Right? So this is, let's say, for example, this is the graphical user interface of your DNS Center. And this DNS Center is going to manage everything. For example, if I go to these three lines, click on here, go to the tools, and go to the topology. These are the tools that are available in the DNS Center. Just click on this topology tab, and you will see the entire topology of your network. Everything. So you have, for example, 12 sites here, 2 sites here. This is everything. Like here, you can check the entire topology from here. If I click, for example, let's say, for example, if I click, let's say, for example, North America, if I click on this, North America, click on this, it will show me the topological structure of that particular location. If I expand this, if I click on, for example, USA, it will show me the topological structure of the USA, California. You can just basically go in the hierarchy and you can see the topology of that particular site. See? And you can just click on the device and you can check the role of the device. You can basically check the information of the device and everything from here. Right? Point is, this is one of the tools. This is one of the tools that you can use to explore your entire network. This is San Jose location. This is San Francisco location. This is, for example, New York location. In a San Jose location, they have a few devices, right? You can check all those devices, like just by clicking on this device, you can get the information from the device, and you can run the, if you want, you can also run the commands as well. Right? You can check everything about the device right from here. You don't need to log into that device from, CLI. You can check everything from here itself. See, everything about that device, you can check it from here. It will open. This is one of the tools. Similar to that, we have other tools as well. We can manage all the license. We can manage the template, everything. You can design the network from one centralized point. You can enforce the policies for wired and wireless user from a centralized point. You can configure. You can create the virtual network. You can create the fabrics. You can create, like, you can connect those sites using some sort of transits. You can add on different services such as umbrella integration. You can do. You can run some IoT services and all. You can create the site-to-site VPN. Basically, in the provision, we can do the configurations on the device. And the assurance means like we can manage everything from one centralized point. These are called workflow. Design workflow, policy workflow, provision workflow, assurance workflow. And these workflows we can use to control different aspects of our software-defined infrastructure. Everything you are going to manage from one centralized point. Everything you are going to manage from this DNS center. Let it be like you want to configure the network, you want to design the network, you want to design the sites, everything you are going to do from this centralized point. So this Cisco SDA, Cisco Software Defined Access. If you see, just take a look here. Cisco Software Defined Access, just take a look at here. If you go to the provision, SD access is just a part of the DNS center that it offers. In the SD access part, we can create the virtual network to perform segmentation, of which you can say VRF. This is VRF. This is VRF. Nothing just does the VRF. We call this in SD-WAN terminology, we call this VPN. Here we call it VN. We can create the sites. We can connect the sites using the transit. This comes under the SD access. DNS Center offers variety of tools to manage our campus area network, and one of it is called SD access. So Cisco SD access is a solution within the Cisco DNA network architecture, digital network architecture, aka Cisco DNS Center. SD access is a solution that it is just one small part of the DNS Center offering. So Cisco SDA is a solution within the Cisco digital network architecture, aka DNS Center, which is built on the intent-based networking principle. It provides visibility-based automated end-to-end segmentation to separate user, devices, and application traffic without redesigning the underlying physical infrastructure. Means if you already have your 2-tier or 3-tier network up and running, you already have 2-tier network design, 3-tier network design, access layer, distribution layer, core layer, you have all that, let's say, you do not need to redesign your infrastructure. There is this thing called brownfield deployment, where we can just, in our campus area network, we can just add the DNS center we can add the DNS center, we can connect these devices to the DNS center, and the infrastructure can be managed from one centralized point. So without redesigning the underlying physical infrastructure, your physical infrastructure will remain as it is, cabling and everything will remain as it is, your protocols and everything will remain as it is. On the top of that, we can add on our SDA solution, our software-defined access solution to manage the things from a centralized point. So Cisco SDA provides visibility-based automated end-to-end segmentation to separate users, devices, and application traffic without the need of redesigning the underlying physical infrastructure. Cisco SDA also automates the user access policies, so the organizations can make sure that the right policies are established for any user on any device with any application across the network. This is done by applying the unified access policies across the LAN and wireless local area network. You do not need to configure the policies for wired and wireless users separately. You can just configure the policy, and the same policy will be applied for the user, no matter if it connects from the wired or the wireless network. And building this next generation SDA solution involves some key foundation elements, such as controller-based architecture, policy enforcement engine, network fabric, programmable infrastructure, so that we can indicate some third-party automation tool to have some sort of network programmability in our SDA solution. So we need to ensure that we have this next-gen software-defined access solution. We need to have some sort of controller-based architecture. We need to have some policy enforcement engine. We need to have a network fabric. And we need to have some programmable infrastructure so that we can integrate our SDA solution with third-party automation tool and use Python scripting and all to control variety of aspects of the SDA solution. So what is the controller-based architecture? What is the controller that we are going to use here in our SDA solution? It's called DNS Center. Who is going to be the policy enforcement engine in our SDA solution? It is going to be ICE. The network fabric, it is going to be like based on layer 2 or layer 3, which is basically fabric is going to be like underlay and overlay. If I write down underlay plus overlay and plus policy, this all is going to come under fabric. Network fabric means a combination of underlying infrastructure, on the top of which you have configured the overlay logical network, logical tunnels, and some policy enforcement engine that is responsible to enforce the policy throughout your campus area network. And programmable infrastructure means some sort of APIs. We need to have these APIs, application programming infrastructure, so that we can also program our SDA solution using third-party automation tool such as Post. So SDA solution is going to use DNS Center as a centralized controller. It is going to use Identity Services Engine as the policy enforcement engine. It is going to use the concept of underlay overlay to create the network fabric. And this is in this Cisco SDA solution, we have our programming infrastructure based on API, application policy. Application programmable interfaces, not API, not ACI actually, API, application programming infrastructure. That allows us to connect our SDA solution, basically DNS Center, with third-party automation tools such as Postman, so that we can change variety of aspects of our network using some API calls. These things are what build our SDA solution, right? So these are the components that are used in our SDA solution. We use routers and switches. We use access point and wireless LAN controller. We use Identity Services Engine. We use DNA Center. These are the devices that we use. These are the physical devices that we use in our software-defined access design in a campus area network. And as far as the protocols are concerned, we can use any IGP protocol to make the devices reachable to each other and to the DNS Center ICE WLC. We can use any protocol. However, they prefer IS protocol. They say that the connectivity that you are going to provide in this network, you prefer ISIS. They say that ISIS protocol we are going to use for the same. We will talk a little bit about the ISIS as well as a part of our content. We are not going to go in detail. Details are covered in the service provider track. We will talk about the ISIS only, that much which is useful for us in our SDA classes. So they say we can use any interior gateway protocol to make the reachability between the devices and to the DNS Center, WLC, and Identity Services Engine, but they prefer to choose ISIS protocol. We can use VXLAN protocol to transmit the data from one edge to other edge, one device to other device. So the VXLAN protocol is going to be used at the data plane, and the Lisp locator ID separation protocol is going to be used at the control plane. We'll talk about that. What is data plane? What is control plane? What is VXLAN? What is Lisp? And CTS, Cisco TrustSec, is going to be used as the policy plane. So these are the protocols that we are going to implement in our SDA solution. We can use any IGP protocol for the reachability purpose. However, they prefer ISIS. We will use VXLAN at the data plane. We will see the use cases of it. Why we need VXLAN? Why we cannot use anything else? Lisp locator ID separation protocol. Why we cannot use anything else? Why we use only Lisp? We will talk about that. And for the policy enforcement, we are going to use Cisco Trust. So we will talk about these, these protocols and these devices throughout our content. These are the devices that are used in our SDA solution, and these are the protocols that are used in our SDA solution. So we will have our infrastructure ready. We will have the reachability between the devices and the devices to the controllers, DNS Center, ICE, and WLC. And then we can create a logical network, which is what we are going to refer to as overlay network on the top of this physical infrastructure. And as per our policy, we will try to send the data from one point to the other. Right? So this is the overview of your software-defined access. So how, just to give you the idea, how the Cisco software-defined access is going to deal with the security challenges. We are not going to implement the security based on VLAN or ACL. Instead, in the Cisco SDA, we can implement the policies to enforce the security based on user group. We can have something called group-based access control, where we can create the policies based on user group. such as auditors, cannot communicate with guests. For example, auditors in our infrastructure cannot communicate with the guest. We can create the policies based on the user group instead of creating the policy based on VLAN or ACL. That's it. That's all you need to do. So anyone that is any user that is categorized as auditor is now not going to be allowed to communicate with the users that are identified as guest, and that's it. Done. So we will not spend a lot of time in creating the VLANs, ACLs, managing those ACLs, managing those VLANs. We're not going to spend a lot of time there. Once we do that, the policy is going to be enforced on the switches, and any user that is categorized as auditor is not going to communicate with the user that is categorized as guest. How? Later. But to deal with those security challenges, we are not going to implement the security based on now ACL and VLAN. We have the option to implement the security based on user group, type of user, what type of user it is, which is what we are going to refer to as group-based access control. Deploying a new device is very simple because I can just go to the provision tab. I can from here go to the inventory. I can manage everything about the device right from here. Right from this inventory tab, I can just do some basic configuration on that device. I can make it reachable to the DNS center, and then everything I can push from the DNS center to that newly added device. We do not need to do the configurations on that device one by one. So I can manage the network devices, all the devices that you have connected, that you have configured in your infrastructure, right from this centralized tab under the network devices in the provision here. We can also discover the devices using a technique called plug and play. Just connect the device in the network, and we can discover the newly added devices with the help of this technology, this thing called plug and play. We can assign the devices to the site. We can go to, for example, inventory. We can, for example, select a particular device, and we can just assign that device to a particular site. And the device, and onto that site, whatever configurations we have done, those configurations will be pushed on those devices automatically. So we do not need to do the configuration on that device manually, one by one. No need to do that. So the deployment of the devices will become like very easy in your infrastructure. To deploy a new device, the deployment of the new devices is going to be very easy in the network. We'll talk more about it, but the deployment is going to be comparatively very easy. Let's say a user reports a problem. So I can go to the assurance. I can go to this, for example, issues and event. I can go to issues and event, and I can see that these are some issues that are reported. P1 issue, P2 issue. We can see these issues. So our DNS center is acting as some sort of collector of SNMP messages, traps, and everything. So I can see that here we got like approximately 25 issues in our network, and I can not only check the issue, but I can do this. Click on the issue, layer 2 symptom. And so it says that in North America, USA, California, San Francisco, office number 13, this issue has been reported. Click on this. We can not only get the information, about the issue, but right from here, we can use machine learning. We can use the artificial intelligence and machine learning. We can just click on this run machine reasoning, and it is going to perform the root cause analysis of the problem, analyze the issue detail, receive the MAC flag, get the information. Okay. It will do some machine learning. It will just do some machine reasoning in the background, and it will suggest to you the possible solution to the problem. See? It can not only tell you about the issue, but it can also suggest the action based on the issue. it has run it runs the that machine learning. It uses the machine learning artificial intelligence capability to not only detect the issue but also do some root cause analysis and give you the suggestions about the issue as well, right here. So you just need to go on the devices and enable the VLAN STP for VLAN 31 because looks like it is disabled. Maybe in the later versions you will also be able to configure this action right from here. At least it is not available in this 2.3 version of this DNS Center. But the operational challenges that you were facing earlier, they can be managed again from this centralized dashboard under the assurance tab. It can not only detect the issues and different events that have occurred, but it can also suggest the action that you can take to resolve that particular problem. So operational challenges that we were facing, we can handle those operational challenges right from here. Just click on this, click on the issue, click on the device, run machine reasoning. It will do some, checks in the background. And once it is done, it will tell you the possible solution that you can take, right? So there are 3 conclusions. Interface is administratively down. Link speed is mismatching. And the cable diagnostic does not detect any physical cable error. That means physical cabling error is not there. And either you have the speed mismatch problem or the administratively shut down interface is there. That's why you are having this issue. So it can not only tell you the problems, but it can also suggest the actions. And of course, we are managing everything from a centralized point. This is the centralized point from where we can manage everything in your infrastructure, in your network. So all the management related challenges, we can have the policies for wired and wireless user right from here. We can manage both wired user and wireless user right from here. We do not need to have different policies for wired user, different policies for wireless user. We don't need to do that. We can manage all these devices right from here. We can manage all the sites from here. We can manage all the policies right from here. We can upgrade the software images on the devices right from here. End of license, end of license, end of life, end of sale status, we can check it from here. Licenses, everything you can manage from here basically. So all the management related challenges can also be addressed via this DNS Center. So you will notice that using this DNS Center in your campus area network is going to add a lot of benefits, but it comes with a cost. It's not a very cost-effective solution, not at least in a shorter term, no. A single DNS Center appliance is going to cost you approximately like 30-35 lakhs. If you go to the Cisco partners and you try to purchase it from there, you might get some discounts and all. Or if you purchase by more than one, you do some very heavy purchasing, then you might get some discount. But a typical cost of the DNS Center appliance, and a regular one, a normal one, it costs around like 30-35 lakhs. And they say have at least 3 of them. So it might not come as a very cost-effective solution at first, but in a longer run, your expenses, your operational expenses are going to be reduced, which is eventually going to cover the overall cost of the solution. Right, so we'll talk more about it, but you just got the idea, you just got a general idea. What things we can do from this DNS Center appliance, we can do everything from the centralized point, and you can explore more options right from this DCloud, completely free of cost, no charges at all. What we will do when we start our DNS Center, it will be completely blank. We will set up everything from the scratch. All the devices, licenses, policies, profiles, everything from the scratch. We will not have this pre-configured DNS Center. This you can use to discover the images, devices. You can explore a variety of options from here, but we will set up from complete scratch. So this is all that you need to know from the introductory point of view, from the introduction point of view of your SD access. And just a little graphical user interface, just a little overview of your GUI of the DNS Center. Later on, we will see how can we create the fabric. Later on, we will see how to build this network and all from the scratch. We will see definitely from the scratch. So this was just the this was the overview of your Cisco SDA solution for your enterprise. So we were talking about different challenges that we had in our production environment, in our modern day network. We had different challenges. In a traditional network, we had different challenges. And we saw that if you want to deal with those challenges related to the operations, challenges related to the security, challenges related to the deployment, challenges related to the management, and other challenges as well, it was a good idea to go with some sort of software that is going to do the configurations on the behalf of us. Like, we will not do the configurations on the devices manually. We will take the access of that centralized controller that we have, and from there we are going on that controller. We will define our intent on that controller. We will define our intent that, okay, this is what we want to do, and that controller is going to push the configuration to all that on all the devices, so that the chances of human errors, chances of like configuration mismatch and everything is very low. So one of the solution that we had in this controller-based networking was Cisco Software-Defined Access, Cisco SDA. So in Cisco SDA, what we have a campus network, we have a campus area network, and we are going to integrate a controller in this campus area network, and that controller is going to be named as DNA Center. So eventually, Cisco SDA Access is a campus area network, campus fabric plus DNA Center. So we have a campus network where we want to implement the software-defined access with the help of this DNA Center controller. This is going to give us the Cisco SDA solution. DNA Center is not the only controller that we might be using in our environment. Apart from the DNA Center, we are also going to use wireless LAN controller, which is WLC, wireless LAN controller to manage all the access points in our network. And we will also be using this identity services engine, which is going to act as the policy controller. From here, we are going to enforce the policy in our infrastructure. So when it comes to hardware controller, we only have this DNA Center. WLC and IES is going to be there also to manage the access point to enforce the policy in our infrastructure. Yes, sir, let me know.
Okay. So basically, sir, doubt here. Just wanted to check. So yesterday we discussed now that what all benefits we got with the help of DNAC, right? कि हम traditional में थे, तो now we have got LAN automation, तो deployment easy हो गया, centralized sub configuration हो गया and everything.
Exactly.
So from the wired perspective, it is like understood कि हाँ ये सब चीजें campus को जो wired network था वो clear out हुआ. बट फ्रॉम अ वायरलेस पर्सपेक्टिव, वायरलेस में तो पहले भी मतलब कंट्रोलर था ही ऑलरेडी, है ना, और उसमें भी सब कुछ ऑटोमेटेड ही था पहले से ही. तो अभी एसडीए के अंदर वायरलेस को मतलब इंटीग्रेट करने से उसमें मतलब क्या वो क्या आया, मतलब बेनिफिट क्या आया?
Okay, let me. So, for example, in an enterprise network, if you talk about from the enterprise network point of view, let's say we have wired user and wireless user. We have two types of users in our production environment. Now, one of the major thing that the SDA is going to enforce in the entire campus network is that the policy. For example, earlier, if you want to control like what devices, like let's say, for example, what SSID, if I talk from the wireless point of view, if we discuss from the wireless point of view, we have to go to the wireless LAN controller. We have to go to the WLC. There we do the configurations of some basic VLAN, SSID. We map the VLANs with the SSID, and we do all that thing. We can enforce all the different types of security, AAA, and everything we can do. Now, when it comes to like policy application, we might need to configure two different set of policies. One policy for the wired user and one policy for the wireless user. Although it is going to be automated, yes, that is completely correct. That I agree. That the policy that you might want to create, you can create like a lot of options are there in the wireless LAN controller. You can do it from there. But the policy has like the administrator need to create two different set of policy. One policy for the wired user, one policy for the wireless user. First, second point is that let's say from the WLC control point of view, like. Where should we place our wireless LAN controller in our enterprise network? So wireless LAN controller can be placed. Basically, there are different deployment methods like unified WLC. We can place it in a centralized location such as data center, cloud. We can place it on the cloud. There are different options like where the WLC should be placed. Third, the traffic in the traditional wireless network, if we talk about how the traffic moves, just in case if you have the idea from the wireless point of view, in the traditional network, you will notice that the traffic that arrives on the access point, right? Let's say, for example, a user is connected onto this wireless, this access point, and the user wants to send some traffic to the other devices. You will notice that the traffic will arrive on the access point, and from the access point, it will be sent over that tunnel, which we refer to as a CAP WAP tunnel, control and provisioning of wireless access point, towards the wireless LAN controller. And from that wireless LAN controller, the traffic will be sent towards the other, let's say, for example, device. Since the wireless LAN controller acts as more like a centralized point from where all the APs are being managed, the data flow will also be via that wireless LAN controller. In the traditional wireless network, unless those access points are operating in a different mode, you will notice that the traffic will flow from the wireless LAN controller. So when it comes to software-defined access, when it comes to the SDA, one of the advantage that you will notice that you will see, that let's say, for example, you have a lot of WLC. Let's say you have a lot of WLCs in your infrastructure. You can integrate all those wireless LAN controllers with your DNS center. By integration, what I mean, you can tell that, okay, this WLC is in the let's say, for example, Dubai location. This wireless LAN controller is in the India location. This wireless LAN controller is in some other location, and you can manage the functionalities of those wireless LAN controller right from there, right from the central DNS center, centralized DNS center. So that is one of the advantage. Second, we do not need to configure. We can manage all the wireless LAN controllers from our DNS center. Our DNS center can basically communicate with the wireless LAN controller, and it can also give us the graphical user interface access, UI access by just clicking on that wireless LAN controller. We can get a detailed information about that wireless LAN controller right from the DNS center. We do not need to, open the wireless LAN controller individually. We can get the information right from the DNS center itself. Second, the policy. We do not need to configure two different set of policies for our wired and wireless user. We can have one unified policy, and that policy is going to be applicable for wired and wireless user. So let's say the user connects itself using a wire onto a switch. Switch is going to apply some policies on that. Even though the user connects itself wirelessly, the user connects itself to the access point in a wireless fashion in the network, then also you will notice the same set of policy, same policy is going to be applied. So we do not need to now configure two different set of policies for wired and wireless user. Third, and probably one of the most important thing, these access points are actually that we are going to use, these WLC that we are going to use in our DNS center, they are compatible with DNS. Of course, that is why we are using it in there. These access points have the capabilities, these DNA compatible access points have the capability to directly build a tunnel with the upstream switch. This is a switch where this access point is connected. This is a switch where this access point is connected. This access point can build, it can build, if I tell you, a data plane tunnel with this switch directly. And that tunnel is what we are going to name is that like VXLAN tunnel, right? This access point is going to build with the switch a VXLAN tunnel, which is what we refer to as data plane tunnel. And all the traffic that you have received on this access point, no need to go, that traffic will not need to go to the wireless LAN controller. It can be offloaded directly from this access point to the switch, and from the switch network, it can go to the wired user, or it can go to the other access point for the wireless access. Right? So you will notice like from the wireless point of view as well, these are a few advantages that you get from the wireless point of view. One, like we have the access to all the wireless LAN controller, like in our DNS center, we can just place those wireless LAN controller into different locations, and we get complete detailed information about that wireless LAN controller right from the DNS center. I'm not saying that you will be able to manage everything about the wireless LAN controller from the DNS center. No, I'm not saying that. I'm saying that you will get a visibility of like all of that wireless LAN controller statistics and everything you will be able to see from the centralized point, the DNS center. You do not need to go one by one on all the wireless LAN controller to check the statistics and everything. More importantly, all the clients that are connected with the wireless network, those statistics will be available in the assurance dashboard of our DNS center, so that you get the idea that, okay, this user is connected in a wireless fashion, this user is connected in the wired fashion, how the connectivity and everything is in. You can monitor everything from that centralized point, right? So there are, you will notice that there are quite a lot of advantages that you get when you connect your wireless LAN controller, or when you connect your WLC with this DNS center, Cisco DNS center that we have in our network, right? More benefits are there as well, but one of the major benefit is that the traffic is no longer being sent towards the wireless LAN controller, and the traffic can be offloaded directly from the access point to the switch, so that the traffic just goes via that VXLAN towards the other device. It doesn't need to go towards the wireless LAN controller. Earlier, that used to happen when the access point works in the flex connect mode. Then that happens, but here it is a normal operation in our SDA deployment.
Okay. So,
Right?
yeah, this point I understood. So, but just from that point, when you said that there will be a unified or a common policy for a wired or a wireless user,
Yes.
that is what we get. So, when you say about the policy, I mean, you're just referring to that part, like the SGT's part only, or
Yes. I'm referring to I'm referring to these policies that you can apply right from here. Right from here, like you can create the policy based on group-based access control, and that policy will commonly be applied for both wired and wireless user. So you do not need to configure the policies for two different types of user one by one.
Understood. And second thing is, when we say this, the AP like makes a VXLAN tunnel with the switch, so the
Yes.
traffic gets decapsulated on switch, then it becomes like a normal wired traffic. So
Yes.
from the AP to this fabric edge switch, basically, so is it mandatory that AP needs to be directly physically connected to the switch? Or if we have a requirement, maybe that we have this SDA fabric, we have the edge switches, but maybe edge switches somewhere, and we may have like kind of a field switch or some other L2 non-SDA switch in between, just as an L2. So
As
what
long
is
as the reachability is there, na? As long as the reachability is there, even though there are some devices in between, it doesn't matter. Like if, let's say, for example, here we have an IP and here we have an IP, and these IPs are reachable to each other, it's okay.
Okay. Understood.
Right? Because from the design point of view, even from the design point of view, if we take a look at this, for example, design that we have, just for the quick right here. For example, if you take a look at this design, even in the wired network, from the wired network point of view, let's say, for example, these devices are SDA switches, but these switches are not even the SDA switches, but still it will work. As long as the reachability is there between these two devices, you will notice that the tunnels will be formed and the traffic will be switched based on the same. So as long as there is a connectivity from this access point to this device, and as long as these two devices are SDA devices, they will form the VXLAN tunnel.
Understood.
So this is what I was saying. Like if I go from this, this is the DCloud DNS center. This is the DCloud DNS center that I have opened, and I think this is a different one because I don't see any number of devices here. So if I go to the provision, if I go to the inventory, here it will list all the devices that we have, and all the devices that we are going to have here. Those devices will also include the wireless LAN controller and all. And we can see the statistics and everything of those wireless LAN controller right here. Let me open the correct one. I don't think like it is the correct one because I don't see any devices. So I will just on the side I will just open the correct one, because I think this is they have a lot of in DCloud they have a lot of like previous version demos as well. So you might need to choose the correct one if you want to do some testing and everything, because not only this 2.3, they might also have some other version of the DNS center as a demo. So you need to select the correct one. So I'm going to select the same that I used in the last class, because there I was able to see the devices. So right here, it was DNS Center for Assurance and Automation demo. I'm going to open it. And Hopefully, will show me the devices. It's not sure what happened. Let me just log out. If it doesn't, you can take a look at the other versions as well. There might be some other older version DNS Center as well. You can just scroll down or just search. It will show as well. Yesterday, like it was showing properly. I will take a look. In not sure if they have the correct one or not. The main point is that we can have the DNS Center managing both wired and wireless user from a centralized point. We do not need to basically go ahead and configure each and every wired policies for each and every wired and wireless user differently. We can do that from the centralized point. The traffic will go directly from the from the AP to the S devices directly without going towards the wireless LAN controller. That is one advantage. Right, and the other advantages are there. We can also manage all these devices from the centralized point. That is one advantage. We can manage all the wireless LAN controller. We can assign the devices to the site. We can assign those wireless LAN controller to the appropriate sites, and we can manage those from one centralized point. That is one advantage. So we definitely have a lot of advantages when it comes to wireless users as well. Yes, so this one. Looks like this one is the correct one. So here I can see 113 number of devices total, 62 number of sites, 97 number of DNA license devices. And right here, I can go to the, if I just click on the devices, then also it will show me all the devices right here. I can just click on the device and I can see it here. I can now filter the devices. I can filter the devices based on the functionality. I can filter the devices as well. So for example, I want to check only the wireless LAN controller. I can just click on wireless controller and I can apply this filter. So it will now only and only show me the wireless LAN controller. So see, these are different fabric enabled wireless LAN controller that they have connected in different locations, such as San Jose. In San Jose location, they have connected a few controllers. Then Seattle location, they have connected a few controllers. Then San Jose site number 6, they might have added Palestine. Basically, in different location, they have connected these wireless LAN controller to manage the APs. Now, if I, let's say, for example, click on any of them, let's say, for example, I click on this wireless LAN controller, right? It is going to open the dashboard, which is going to give me all the information about that wireless LAN controller right from here. We can also run the commands right from here. We can manage a certain amount of things from here. We can check everything in detail about that controller from this device 360. View 360 means give us the complete information about that wireless LAN controller. I can check everything about that wireless LAN controller by this 360, this option, right? And we can also check the ports, like what ports are connected, what ports are not there, what ports are up, virtual ports, hardware, software version, configuration differences, if current running configuration and the startup configuration is synced or not. We can get the wireless information as well, how many sites this is managing and all. So we basically get everything. We get all the information in detail. And for more detail, I can click on this View 360 and it is going to open this dashboard and it is going to list everything about that particular device right from here. We can check the issues, we can check the issues here. First thing, we can check different issues that we are facing on there. We can check the topology. Here, this is how the topology is there actually. This is fabric enabled wireless LAN controller. This is the AP. This is the code. This is how the devices are connected actually, right? This is the health. This is number 8, number 10. It is basically the health of that controller, right? We can do the trace. We can check the application experience. We can check the detailed. Basically, we can take a look at a lot of things. And we also, let's say, for example, I can also take the GUI access of that wireless LAN controller. It's not like we can still type in the IP address of that controller and we can get the access of that GUI access of that wireless LAN controller as well. So I'm not saying that we can manage everything from here, but still we get a better visibility of entire network wherever we have connected those wireless devices. In fact, access point, clients and everything, we get a better visibility of the same from this DNS center. Very limited options are there about the wireless, that I must say. They are continuously trying to add new features in the wireless, but at the moment, there are very limited features that we have from the wireless point of view. Yes.
Okay. So just wanted to confirm. So like, there are, let's suppose we created SSIDs or something from the DNAC, right? Now, the same config tab in the WLC, will that be just become read only? Or if if we can log in
yes,
there
yes,
also
yes,
and
yes,
configure
yes,
that. Otherwise, there will be contradiction, right? Some people, sometimes we may configure there, sometimes we may configure it. So
yes,
synchronization
we will see that. We will see that. Yes, we will see that. Actually, we will try to, we do have a WLC. We will try to integrate it with our DNS center, and we will create a basic SSID on here on our DNS center, and we will see how it is propagated on there. Basically, it's more of a sync operation. Like it's more of a sync operation. It's we will see. We will see in the wireless section. We will talk about that. But it's more of a sync operation rather than being, read only, as just like, for example, in case of ICE. We'll talk about that. But the point is, we can actually define the SSIDs and everything. We can define the wireless profile. In the wireless profile, we can configure. In the wireless profile, we can configure the, for example, here we can configure the SSIDs and everything, and we can push these SSIDs towards the devices. So you will notice that these SSIDs will be propagated towards the our wireless LAN controller actually. But will it be completely read only, or is it going to be like more of a sync operation? We'll talk about that. Right. API and WLC, we are not going to cover. We are not going to cover about the wireless. We will see the integration of the wireless LAN controller as a part of our content. Right. Okay. So yes, we get certain advantages of the wireless LAN controller or the, while from the wireless point of view also, we do have certain advantages here. Okay. Now, coming back to this is the last thing that we talked about, that what type of devices we have here. We have router switches, we have access point, we have WLC, we have identity services engine, we have DNS center. These are the physical devices that we have from the device point of view. Then when it comes to the protocol, we have IGP protocols. Any protocol you can use to make the reachability, however they prefer ISIS. Then we have VXLAN at the data plane. Then we have Lisp at the control plane. Then we have CTS, Cisco TrustSec, at the policy plane. Right. AP and WLC means access point and wireless LAN controller. Access point and WLC means AP means access point and WLC means wireless LAN controller, which is part of wireless. Now, so Next, the devices, like the use cases. The use cases of the SDA. So from the use case point of view, what are the things that we have from the use cases point of view? So Cisco SDXs can now deliver business-driven use cases that realize the promise of digital enterprise while reducing the total cost of ownership. Like I said, in the longer term, if you talk about in the shorter term, it is not going to be a very cost-effective solution. You will notice that you might need to purchase the DNS center, you might need to purchase like 3 DNS center, you might need to purchase devices if they are not compatible and all. Right, that thing. But from when we talk about from the longer run point of view, you will notice that the DNS center is going to prove quite a lot cost effective. In the shorter term, no, of course not, because you will also need to purchase the devices and everything. You also need to purchase the licenses and everything. So license is not going to be a permanent license. It is going to come at a cost of some subscription and all. So overall, you will notice the cost and everything is not going to be in a shorter term. The cost is not going to be very less. And in the shorter term, when we want to deploy the DNS center, the costing is going to be quite a lot. You might get the discounts and everything, but in the longer run, the amount of money that you pay for the operational expenses and all, overall, it is going to cut quite a lot. Right. Yes, Devashish.
So here in wireless, every model of access point and wireless LAN control will work with SDXs, or there is some limited?
There is limitation. We will, when we talk about like physical devices, there we will see the compatibility. We will see the compatibility, what devices are actually compatible with the SDA. So no. In short, no.
Okay, right.
So like not even the switches that you have in your production environment, not even those switches might be compatible with the DNS center. So that's what I said. Like you might need to purchase new switches, for example, like if those are the old ones are not supported.
Okay. In case if any enterprise wants to implement SDXs, they need to replace all the devices.
They might need. Yeah, they might need to, because if they have, let's say for example, if you in your production environment, let's say you have Catalyst 3650 series switch, right? That is compatible. 3850, that is compatible. But if you have 3750, that is not compatible. So the point is that there is a specific hardware on these switches that has to be present. That is more like that allows the SDA implementation on those devices. There is a dedicated chip, ASIC, application specific integrated circuit, that needs to be present on these devices. So if your device has that application specific integrated circuit, ASIC, then it's okay. It's compatible with the DNS center. But if it's not, then you definitely need to consider buying new devices. And that is and again, then let's say, for example, you have your infrastructure up and running completely fine for maybe 2-5 years, everything is working fine, and then Cisco says that okay, you can implement SD access in your network to get increased visibility in your network, so that you can determine, create, and apply and monitor all the policies from a centralized point, so that you can have zero trust security for the workplace. You can handle the user mobility with the help of access point and wireless LAN controller from a centralized point as well. You can ensure the different policies for the guest user access. You can control what the guest users can access, what cannot, so that you can also integrate the IoT devices in your infrastructure, so that you can do the monitoring and troubleshooting from a centralized point, so that you can integrate cloud, data center, and branch all with the DNS center. These are all the benefits that you get from the DNS center actually. But the point is, if you have a network of, let's say, for example, 20-30 devices, and you have similar to that, let's say, for example, you have 6-10, let's say, for example, location, You have 10, 20 locations, for example, and now you are trying to implement the SDA. And to implement the SDA, you might need to change the hardware. You might need to change the protocol that you are running in the underlay. It is going to be a very time-consuming process, and it might impact your network services quite a lot. And that is one of the reasons why a lot of companies have not, migration is a process that for the migration, they have a guide as the access migration guide they have. So they say that if you have a traditional network, how can you migrate from the traditional to the SDA? Same goes for the SD-WAN. Like they have a migration guide for the SD-WAN as well. So if you're traditional WAN, how can you migrate to the SD-WAN? But changing the protocol from EIGRP to ISIS so that your DNS center is able to automate the network. A lot of companies have, rejected this, the use of this DNS center in their environment. But as the companies see the advantages of using the DNS center in the network, sooner or later, they of course will, they are going to implement the DNS center in their environment. But at the moment, it's not that much popular as the SD-WAN, I would say, because of these challenges that we have. Just give me a second. Right. So because of these challenges that you might need to, first of all, you might need to purchase new devices because your existing hardware is not going to be compatible with the DNS center. Second, you might need to change the protocol because they expect, for example, ISIS and you are running EIGRP. Third, you need to have at least some understanding of the VXLAN, some understanding of the list, so ISIS also. So, and then from the migration point of view, if you implement the DNS center right away, your existing services might get disrupted. So there are a few challenges that are currently there. And that is one of the reasons why a lot of companies have still not considered implementing the DNS center. And more importantly, it's hardware. It's hardware. Like if you have to, for example, test it, how are you going to test it? If you have to test it, if the SDA is going to be beneficial to your company or not, how are you going to test it? For the SD-WAN, let's say, for example, SD-WAN, at least we have some virtualized environment. We can create a topology on software such as EVNG. We can build them, we can create our topology in that network, and we can first of all test everything. And then when we see that, okay, it is beneficial to us, then we are going to implement the SD-WAN in our network. How are you going to do that with the SDA? There's no simulated environment for the same. This right here, it is just to read only. This is not going to give you that much amount of access to the devices and everything. Of course, it is not going to be your company's topology. It is just a random topology. But since they have said that they are working on some software version of the DNS center, they will most probably launch it soon. When the companies see the benefit of using the DNS center in their enterprise network, you will see the DNS center is going to, it might become as popular as the WAN is currently nowadays. So it gives us a lot of advantages, no doubt. It gives us a lot of advantages, but those advantages come at a cost. Cost in terms of devices, cost in terms of licenses, cost in terms of DNS center itself, at least like 3 in a cluster for the high availability and all. So it will come at a cost. If you are able to, and the migration, when you do the migration, your existing services might get disrupted. You need to have some sort of downtime for the same. So if your company or if you are able to handle all these things, the cost and everything is not that much of a matter, then okay, you can implement the SDA to get a better visibility, create the policies, basically have a centralized control over every aspect of your network from the DNS center. So it has quite a lot of advantages, but again, you have to deal with a few challenges alongside like when you are doing the migration, doing the deployment. Right? So when it comes to the use cases, Building on the foundation of industry-leading capabilities, Cisco SDXs can now deliver key business-driven use cases that realize the promise of digital enterprise while reducing the total cost of the ownership. It gives us increased visibility of the enterprise network. We can determine, create, apply, and monitor the network policies from a centralized point. We can add the devices. We can have this zero trust security model in our workplace, which means that every device needs to be. I do not trust this device. Every device needs to be properly authenticated and authorized before it can gain the network access. So we have this zero trust security for the workplace. We can handle the user mobility from one centralized point as well. We can control things such as can control things such as use of roaming and everything from a centralized point. Access point and WLC altogether is going to give us a very big disjoint wireless local area network that we can manage from our DNS center. We can create different set of policies for the guest user so that they do not interact with the wired user or let's say corporate user. We can integrate different type of IoT devices because in modern day network, IoT is gaining a lot of popularity as well. We have different sensors, IoT devices, cameras, and everything. We can integrate a few IoT devices in the DNS center as well. We can do all the monitoring and troubleshooting from a centralized point. We can integrate our branches, data center, and cloud, everything with the DNS center. DNS center is hardware. That means there is a hardware device that you need to purchase and install it in your infrastructure. There is no software that you can deploy on some server. That is one thing. SD-WAN devices, SD-WAN controllers that we have, these are virtual devices. Like you can just download the software image for the SD-WAN controllers, vBond, vSmart, and vManage, and you can run it in a simulated environment such as ESXi. Right. So if you have like enough resources, computing resources, if you have enough resources onto the device, you will notice that you can run those SD-WAN controllers in a simulated environment. In fact, like if your EVNG software supports the deployment of the SD-WAN images so that you can do the testing and everything from one centralized point. Right. So hardware means like you need to purchase. Hardware means hardware basically means that you need to purchase the device hardware, and the software basically means that you can implement it in some ESXi environment. You can connect all the devices. You can connect all the devices. All the devices that you want to manage from the DNS center they have to have some sort of reachability to the DNS center. It could be like completely physical reachability, wireless, doesn't matter. Yes, you need to connect all the devices to the DNS center so that you can manage them from the DNS center itself. The reachability you have to ensure, and which is going to be our part of underlay. How we are going to build our underlay network to make sure that all the devices are reachable to the DNS center. So yes, reachability has to be there from the switches, from the access point, from the WLC, from the IEs to the DNS center, so that integration and management can be done from the centralized DNS center. Yes. It doesn't need to be directly, like, it does not need to be in the same subnet. We can have our DNS center, vManage, vSmart, vBond in a data center. And we have our branches. We have access point in the branches. We have WLC in a data center or WLC in headquarter, right? And headquarter, branches, and data center devices all are reachable to each other. There will not be any problem in managing all those devices from the DNS center or WLC or SD-WAN controllers. All that matters is the reachability. If the reachability is there, it is not going to be a challenge. Right? So these are a few advantages that we see in our, these are a few use cases that we see in our DNS center deployment, in our SD access basically with the DNS center. These are the benefits that we actually see. Enhance endpoint visibility by using advanced analytics for user and devices identification and profiling. We can employ artificial intelligence and machine learning techniques to classify similar endpoints into logical group, and we can define the policies for those logical groups. So a group of devices that are like similar in terms of functions and all, then we can logically group them. We can group those endpoints logically, and then we can define a policy with the help of thorough analysis of the traffic flow between the endpoints and group. So, endpoint group concept, endpoint group and policy concept is very popular in your data center environment. So that same endpoint group and policy concept we can implement in our enterprise network as well. Whatever set of devices are similar in function, like whatever set of devices are actually similar, similar types of endpoints can be defined in a logical group. And for those groups, we can create the policies, and that policy can be enforced in the entire network using the graphical user interface. So for example, we have HR users. We have like 10 users that belong to HR, or let's say, for example, IT department. So what I can do, I can say that when this user connects in our network, when this user connects itself to the switch, right? This user is going to be assigned some sort of group tag. This user belongs to IT group, and everyone that belongs to IT group will be assigned a tag value of 90. Then I can say like, okay, when this user connects itself onto the switch, this user belongs to finance group. The user is going to be assigned a tag value of, let's say, for example, 100. So we can group the similar type of user logically, and then we can, let's say, for example, assign them a tag value. And then we can create a policy that if a user has tag number 90, they cannot communicate with the users with the tag number of 100, which will effectively block the communication between IT and finance department. This can be done by creating those policies in our DNS center. And these policies are going to be enforced by the identity services engine that we have already integrated in our DNA center. Right? So enhance endpoint visibility by using advanced analytics for the user and device identification and profiling. We can employ artificial intelligence and machine learning technique to classify similar endpoints into logical group. And then we can create the policies for these groups with the help of thorough analysis of the traffic flow between two endpoints. And we don't need to use any CLI command. It is all going to be graphical. Like we can use the graphical user interface to configure the policies and everything from one centralized point. So we can group similar type of users, and we can create the policies for those users from the DNS Center graphical user interface. No need to configure any CLI commands or anything for the same. We can also create virtual network, virtual overlay to segment both wired and wireless network uniformly and separate unrelated traffic to provide just the right level of access to endpoints, boosting compliance and reducing the business risk. So we can create these logical overlay networks. We can create these logical segments. We can create these virtual overlay to segment. Segment is basically divide both wired and wireless network uniformly and separate unrelated traffic to provide just the right level of access to endpoints, boosting compliance and reducing the business risk. Exchange operational policies to ensure consistency by utilizing the intent-based networking, multi-domain architecture for enforcement throughout the access, WAN, and multi-cloud. On it doesn't matter where you have placed your device. It does not matter if your device is placed in a data center, if the device is placed at the access layer, if the device is a WAN device, we can configure and manage all the devices from a centralized point with the help of this DNA. So again, same thing. We get increased visibility. We can configure different types of policies. We can enforce proper authentication, authorization techniques before the device is allowed to access the workplace network. We can configure the user mobility, configure the guest access, configure the IoT integration, monitor the network, do some troubleshooting, and we can integrate our data center, cloud, branches, all that all together with our SD access. So these are the benefits that you get. These are all the benefits that you get. These are the features that we get in our DNA center, in our SD access, basically with the DNA. Cisco SDA gives time back gives IT time back by dramatically reducing the time it takes to manage and secure your network and improving the overall end user experience. So as per the studies, like this is again from Cisco itself, like there is going to be like 67% of saving in your network provisioning time, 80% less time to resolve the issue. In a 5-year return of investment is going to be approximately 462%. As per Cisco, as per them, if you implement the SDA right now, the 5-year return on investment is going to be approximately 400%. At the moment, it is going to cost you a lot, but if you compare that investment with the 5-year expenditures that you do in your company, it is going to prove very cost effective. 48% reduction in the security breach, because we have configured some policies for the both wired and wireless user. We have integrated IEs so that we can have better security in our network and all. It is going to reduce 45% reduce the total cost of operation, 49% more efficient network management staff. These again, this is from the percentage wise it says that DNS Center implementing the Cisco SD access in your enterprise network is going to give IT back time by reducing the time it takes to manage and secure your network. This is again some statistics that they have shown in some of their presentation. Right? And we can migrate from, like we can migrate. They also have this thing called migration guide. So it's not like you have to implement, you have to deploy the SDA from complete scratch. For the new networks that we have, we are going to deploy some new networks. We can perform things such as micro segmentation using IEs. We can design our new network as per our requirement. We can have like macro segmentation. We can create the endpoint policies and group. We can do the micro segmentation, and then we can have full SD access in our environment. So SD access can not only be added. SDA is not only going to be added in the existing network, but in the new network, but we can also add it in our existing infrastructure as well. We just need to have a DNS center, 1 or 3 or like more than that. We need to have the DNS center. We need to make sure that all the devices are reachable to it, and we need to make sure that the devices are compatible to it. And then we can migrate from the traditional to the SDA. So this is more like a greenfield deployment. This is more like a greenfield deployment where we are deploying everything from the scratch. And this is more of a brownfield deployment where we already have our infrastructure up and running, and we are going to migrate from the traditional to the SDA. Organizations wishing to convert their existing network to the simplicity, automation, and security that the SDA offers can do with minimum disruption to their users and connected devices. They have a migration guide that you can refer to if you want to migrate from the, how you are going to migrate the layer 2, how you are going to migrate the layer 3. They have given all that in detail. We will study a little bit from there when it comes to the migration in our SDA network. So they say that we can not only build the, we can not only deploy the SD access from the scratch in a greenfield deployment, but we can also have this SD access deployed in the existing network, which we are going to refer to as brownfield deployment. And after the migration and everything is done, you will get full SDA capability in your network. Overview, the components. This is our SDA fabric. SDA fabric basically means a set of devices where we are running the software-defined access SDA network, right? So SDA, we have our DNS center up and running. The DNS center is connected to this SDA fabric. It can live outside the SDA fabric, like it can be somewhere in the data center, for example. It gives us the capability to do the provisioning. It gives us the capability to apply the policy. It gives us the capability to do some automation. It gives us the capability to do assurance, which means monitoring of the entire SDA fabric from one centralized point. We have different devices. We can add these IoT devices such as cameras, smart bulbs and all. We can have, with the help of some IoT extension nodes, we can connect these IoT devices in our SDA fabric. We can enforce the policies for them. We can configure the policies for the wireless client. So even if the user moves from one point to other point, policy is going to remain as it is. Doesn't matter if the user is connected onto this access point or if the user is connected onto this access point. This IoT network is completely isolated from the employee network. So employees have no access to the IoT network. IoT devices have no access to the employee network. So we can have things such as macro segmentation, and we can have things such as micro segmentation, which is like in the employee network, we have 3 departments like HR, IT, and finance. And I do not want these 3 departments to communicate to each other. That is what we are going to say micro segmentation. And this is what we are going to say macro segmentation. One is done with the help of concept of VM, and the other one is done with the help of the concept scalable group. We'll talk about that in detail later on. So we get a complete visibility of the network. We can identify and group the endpoints, map their interaction, and define the access policies for them. We can create group-based policies and the segmentation as well. We can enforce group-based access policies and secure the network through segmentation. Policy is going to be consistent throughout the network, even though the user moves from one device to another device. We use the Cisco multi-domain architecture for consistent access and security policy throughout the enterprise network. And this is again repeatedly same thing. What things we get from the SDA point of view? This is the same thing that we have studied earlier. So Cisco SDA is an enterprise network solution based on intent, where the administrator is going to define its intent onto the controller, and the controller is going to configure that intent in the network. An intent-based network views the network as a single system that translates and validates the business goals into the network and returns actionable insights. Cisco SDA Access is composed of 2 major components. One is called Campus Fabric and the DNS Center. Campus Fabric is the underlying infrastructure that has to be managed via DNS Center, and the Cisco DNS Center provides the automation and assurance for the establishment and monitoring of the Campus Fabric. So Cisco SDA is Campus Fabric plus DNS Center. We have here our traditional devices, such as server, such as switches, routers, and everything. We have our traditional devices all connected together, all reachable to each other. And this infrastructure, this network, this underlying infrastructure that is going to be managed via the DNS Center. This underlying infrastructure is what we refer to as the underlay network. What is this underlay network? What is this underlay network? Underlay network is the underlying infrastructure on the top of which a logical network is built. When we use the DNS Center to manage all these devices from a centralized point, we will build a logical network on the top of this underlay network, which is what we are going to refer to as overlay network. So underlay is the underlying infrastructure of consisting of devices such as routers, switches. We have like servers, endpoints, and all connected together, all reachable to each other. I can ping from this device to this device. The traffic will go via these physical devices. Proper routing and everything has to be there so that the reachability can be enforced. So this physical infrastructure, this physical underlying infrastructure is what we are going to refer to as the underlay network. And the overlay network is a logical network that is built on the top of the underlay network. You can relate it with the GRE, with the DM VPN, network that we have in our traditional case. So for example, we can form a tunnel from here to here. We can form a tunnel from here to here. Tunnel is basically a logical path. Tunnel provides a logical path so that I can send the traffic from one point to other point. So an overlay is referenced as to fabric, and it is a logical topology that is placed on the top of the topology independent physical underlay network to connect the devices actually. The overlay network is the logical network that is built on the top of the underlay network. And to build this overlay network, we are going to use our Cisco DNS Center. This overlay network is going to be built and managed via the DNS Center. by assigning the roles to the devices, by configuring variety of tunnels between the devices and all, that is done here. Typically, the overlay network is referred to as a fabric. And overlay network is a logical topology that is placed on the top of the topology-independent physical underlay network to connect the devices virtually. So we have our underlying infrastructure. We have our underlying infrastructure on the top of which a logical network will be built. And that logical network is going to be named as the overlay network. Apart from that, to build this overlay network, we are going to have our DNS center. DNS center will be responsible to build this overlay network. How? By assigning the roles to these devices. These devices that we have in our underlay infrastructure, we are going to assign the roles to these devices. For example, this device, I am going to say this is an edge device. This device, I am going to say that this is an edge device. This device I am going to configure as an edge device. When we do the configuration, when we set the role, when we assign the roles to the devices, you will notice that a logical tunnel will be built from edge to edge automatically. A logical tunnel will be built from edge to edge with the help of some protocol, but a tunnel will be built automatically from edge to edge. And this logical tunnel that is built from edge to edge from one point to other point, this logical tunnel that is built will be used to carry the data from one point to the other point. And this logical network that is built on the top of this underlay network is what we are going to refer to as the overlay network. So overlay network is referred to as fabric, and it is the logical topology that is placed on the top of topology-independent physical. And it connects the devices virtually. It would look like these two devices are connected, but not directly, virtually. It would look like that these two devices are connected, but not directly, virtually. Same goes for this one. So our traffic from this, for example, edge device to this edge device is going to be tunneled. The traffic from this edge device to this edge device, our traffic is going to be tunneled. And every time you hear the word tunnel, just think of some extra encapsulation that will take place on the data, and the data will be sent on the physical infrastructure. Eventually, ultimately, the data will go via physical infrastructure only. But since we are saying that the traffic is tunneled, it just means we are saying that the traffic is tunneled. It just means that before passing the data to the underlay network, some extra encapsulation, some extra information will be added on the data. What extra information will be added? We will see that later on. So every time you hear the word tunnel, there is no tunnel in reality. It's not like there is an actual tunnel from here to here. Even in case of GRE, DMVPN in the traditional network, it's not like there is an actual tunnel from one point to other point. Tunnel is a concept that connect two or more devices logically, even though they are not connected directly. The traffic that flows via tunnel, it looks like the traffic is sent from one device to the other device directly, but actually the traffic is being passed via the physical infrastructure itself. So tunnel is just a concept. Tunneling that we talk about, tunnel is just a concept to send the data from one device to other device that looks like the data is being sent directly, but actually the traffic is going, the traffic is flowing via this underlay network end to end. So just think about tunnel. Every time you hear the word tunnel, just think about some extra encapsulation that will happen on the data before the data passes via physical topology. And that will be what referred to as that the data is being tunneled, that the data is being sent via some tunnel. So this is all that we need to know from the basics point of view in our SDA. That's all from the basics, like what is the benefits of this software-defined access, what things we get, what are the components in the software-defined access from the topology point of view, what protocols we use, what devices we use. This was the complete overview that you can go through. This is effectively chapter number 1 from your Cisco Press book that we have, or the other book that I showed you. This is more like the chapter number 1. This is all that we need to know from the basic point of view. If you go to the chapter number 1 from your Cisco Press book, they have explained that, okay, why did they create the DNA center? What was the use case in a modern network? What things are there? What things are not there? They have explained everything. Right? Any doubt, any question so far? Let me know. Any question, any? Everything clear? So should we proceed then? Aage? Let's continue. Any doubts, anyone so far? Just let me know. Yes, let me know.
हेलो
Yes.
सर अभी आपने जितना भी पढ़ा है ना वो अच्छे से समझा, ऐसे कुछ नहीं समझा नहीं है, पर अगर कंफर्टेबल आप रहोगे मतलब तो फिर हिंदी में थोड़ा सा मतलब ये एक्सप्लेन करना ना अगले जो भी सेशन से वो.
No, class will remain in English as instructed to me from Mr. Saurabh and Sugan. So the class will remain in English. Because some other candidates, some other students, or the recordings might be used later on somewhere. So the class will remain in English. You might try, if you want, like you can join some Hindi only batch. I think in the evening they might start a batch later on, but this class is going to be in English as instructed to me from Mr. Saurabh. You can have a discussion with Mr. Sugan and Saurabh, and they will inform you about the Hindi batch just in case if there is. Right. So this is all the basics. This is everything that you need to know. Now, let's talk about the architecture. Let's talk about the architecture of the Cisco Software Defined Access SDA. Yes, Sandesh. You can unmute. Yes.
Yes, sir.
Yes.
So you are telling that overlay network build a tunnel, right?
Sorry.
So can you hear me, sir?
Yeah, I can hear you. Yes.
Okay. So you are saying that overlay network build the tunnel, right?
Yes. Overlay network will be built with the help of tunnels. Yes.
So after building the tunnel, the header is extended, right? Extra encapsulation is happened there, right?
Yes.
So
yes.
Does device need to process extra to remove that encapsulation later on? So that's
Exactly.
why would it make it some network sluggishness?
Then ideally not, because we are going to adjust the things accordingly. MTU and everything we will adjust accordingly. So no.
Yeah.
What happens actually, just to give you the idea, when we deploy our SDA infrastructure, what we do, we generally set the MTU settings. We change the MTU settings to 9100 bytes, right? Okay. So even if we have some, 9,000 bytes, for example, let's say beyond 1500, let's say some devices support up to 9,000 bytes of data being sent from the physical interface, jumbo frames and all. Over that, 100 bytes of extra information can also be added. So 9100 bytes in total can be there, no problem at all.
So,
but they need to process that extra information. That is true. When the traffic arrives, the extra information will be added. When the traffic is sent, the extra information will be removed. That will be there. That will be there. But it will not add that much performance penalty or anything like that. No. Because these devices are compatible and there is a dedicated hardware for the same, right? So things are things are happening at the hardware level rather than being on the software level. So performance penalty on the CPU and everything is not going to be there.
Okay, thank you, sir.
Yeah. Right. Any more question? Anyone let me know. Right. And so now let's talk about the architecture. Let's talk about from the architectural point of view, what things are there. So when it comes to the SDA architecture, this is now we are going to start everything more like technical from here. So when we talk about from the architecture point of view, you must have already heard about that OSI model, that TCP IP model. You must have heard about two-tier architecture, three-tier architecture. Similar to that, when we want to design our SDA network, when we want to build our SDA network, we have from the architectural point of view, we can divide our entire. In fact, in the SD-WAN also we have like a control plane, data plane, management plane, orchestrator plane. There also we have the same. Similar to that, when we talk about from the SDA point of view, from the SDA architectural point of view, from the SDA architecture point of view, we can divide our SDA network into a few layers. We can understand the roles and responsibilities of the SDA infrastructure with the help of these layers. So from the SDA architectural point of view, there are 4 layers that come into the picture. We have this thing called SDA physical layer. We have SDA network layer. We have SDA controller layer. And we have the SDA management layer. There are 4 layers from the architectural point of view, and SDA network can be divided into 4 layers. So physical layer, network layer, controller layer, and the management layer. Every layer, has its own set of devices and or protocols roles. Each layer has a set of devices. Every layer has some, either they will have devices or they will have protocols, they will have role. Each layer has a set of devices and or roles, protocols, and everything they will have. Physical layer has physical devices and roles set on those devices. Network layer deals with the underlay and overlay network. Controller layer includes the controllers used in our SDA, which is like DNS, Inter, ICE, and WLC. Management layer handles how we access the controller using graphical user interface or application programming interfaces, APIs. So every layer has its own roles and responsibilities. We will go through like each and every layer to understand better about the SDA. So SDA physical layer deals with physical devices and what roles we can set on those devices. SDA network layer is going to deal with the underlay and how can we build the underlay network, how can we build the overlay network. That is done at the network layer. Controller layer includes the hardware controller, DNS Center, or ICE and fabric enabled WLC, all these controllers that we have in our SDA deployment. And management layer deals with like how we are going to manage. Management layer deals with like how we are going to manage these devices. Are we going to manage these devices using APIs, or are we going to manage these devices using graphical user interface or GUI? So first thing first, the physical layer, the software defined access, the SDA physical layer. We will talk about the roles and responsibilities of the devices that we add at the physical layer. So devices and roles in the SDA physical layer. What devices? As the name says, physical layer is going to include the physical devices that we are going to use in our software defined access infrastructure. So what devices we can use in our SDA infrastructure and what are the rules that we can set on those devices is going to come under this SDA physical layer. So SDA physical layer, as the name suggests, physical layer consists of physical devices that are used to build the SDA network. So all the devices that you use to build your SDA network, those devices are going to come under physical layer. Physical layers are going to include, importantly, mainly physical layer devices are going to include switches. we also have the routers, but like more or less, you will notice that the physical layer is going to deal with the switches that we have in our infrastructure. Because we are talking about LAN, we are talking about local area network. Typically, a LAN network is built based on switches. So we are going to have switches in our campus area network. We are also going to have routers in our campus area network, but more or less in the LAN, in the local area network, we are going to have more switches than the router. So we will have quite a few switches. We are going to connect all those switches all together, and then we will be responsible to make the reachability between those devices and make the reachability to the DNS interface. So as the name suggests, physical layer consists of physical devices that are used to build the SDA network. Different devices are assigned different roles in the SDA fabric, and they behave based on the roles that they have been assigned. So what roles we have assigned on those devices? Whatever roles we have assigned on those devices, based on those roles, they are going to behave. They will behave based on the roles that we have assigned on those devices. And what roles we can assign on those devices? We have this thing called fabric S node, control plane node, border node, WLC, fabric enabled WLC. These are there are 4 roles that we can assign onto the devices. We can set a device as an edge node. We can set a device as the control plane node. We can set a device as the border node. We can set the role WLC, fabric enabled WLC on wireless LAN controller. We can enable the fabric WLC role on the wireless LAN controller, so it is allowed to join the SDA fabric respectively. So we are going to have switches, a lot of switches from the design point of view. So let me use a simple software to build a basic network. So again, just for simulation purpose, I'm going to use this software. You might already be familiar with this. This is our good old Cisco packet tracer. I'm not saying that we will be able to implement the DNS inter here, but at least from the design point of view, we will be able to understand. So we are going to have some physical devices. So let's go on the switches, and we are going to have quite a lot of switches here. We are going to have switches that we can configure in our network. So for example, this is like 1, 2, 3, 4, 5, let's say, for example, switches we have. These switches are connected with some other switches. Let's say, for example, 2 here, 2 here. Or only 2 are going to be enough, just in case if you want. So 1, 2, 3, 4, 5 connected via 2 switches. It's going to be enough. And then here we have our more like core switches or border switches. So these switches that we have in our traditional network, these switches are what we refer to as access layer switches. These switches are what we refer to as access layer switches in our traditional network. These switches that we have in our traditional network, we are going to refer to these switches as the distribution layer switches. These are referred to as the core layer switches. And these core layer switches then now are connected to the routers that we have in our network. So let me have a few routers as well. This is one router that is going to connect us to some known network outside our SDA. And this is the router that is going to connect us to our unknown network outside the SDA, such as internet. So connectivity point of view, this is how we are going to connect it. Every access layer device will be connected with the 2 distribution layer switches. I'm going to disable the cable number so that the design is clean, something like that. So we have physical devices. As you can see, we have switches. We are connecting those switches all together. We are connecting all those switches all together so that we can have the reachability between the switches. So like that. Here. Like right. So from the design point of view, this is the, if I say access layer in the traditional network, This is the distribution layer. This is the core layer. And this distribution layer device that we have here, this distribution layer device is connected to the core layer devices, and core layer devices are connected to router. This router is going to connect us to a known destination outside our SDA, such as our, let's say, data center, headquarter, could be anything, but it is known destination. Known destination basically means that this is our branch, our sites, for example. So this is going to connect to our known network, and this is going to connect our SDA network outside the SDA. That is to unknown destinations such as internet, right? So I'm going to use a few routers to represent that this is internet. And of course, I'm not going to connect this. Do we have ports here? Doesn't look like we have them. So I need to add some additional ports here. Just give me a second. I will add some ports here for representation purpose. Going to add some serial port here. Again, this is just for the representation purpose. Just to show you that we are connected with the devices. This is just for the representation purpose. So we are going to connect this, our device, with this, and this I'm going to connect with our known destinations outside the SDA. So we can say that this is our edge router in our branch, which is going to connect to some service provider such as MPLS, and via MPLS it is connected to our other branches, our data center, other locations. It could be any transport. This is transport. It could be public transport, private transport. This is just a WAN transport. You can have any WAN transport that we want. It does not mean that you are going to have just a public transport. You can have any WAN transport. It doesn't matter what is this transport. You can have like any WAN transport here. This is just representing the WAN transport. This is just WAN transport. Similar to that, this is our branches, like our headquarter branches, whatever you might want to say. These are, again, these two are known destinations. These are our headquarter branches, whatever you say. Similar to that, here we have internet. This is unknown network. This unknown network that we have is the internet. And to connect to this unknown network internet, I'm not going to connect the internet directly on my router. I might have some firewall involved here in between as well, and I'm going to connect. I'm going to terminate the connections on the firewall, and then from the firewall, I'm going to connect to the other device. So you can just think that there is a connection between these two as well, right? Because we are running out of ports, so we need to add some extra module on here. Then we will be able to connect it. This is the unknown destination. This is the known destination that we are supposed to connect. Now, we can also have the access points, APs. Let's take some access point because they also are going to come under the physical layer. So if I go to the wireless devices, we have some access points here, such as here. These are APs. So we can have some access points here. Maybe at every device, we have connected an access point, and we have a wireless LAN controller connected somewhere, let's say, for example, here, connected somewhere here. Doesn't matter where. You can have the wireless LAN controller connected at certain location. Right, so this is access point. I'm going to connect this to here, connect it to here, connect it to here, connect it to here, connect it to here, and here is our wireless LAN. Right, we can have the wireless LAN controller in our headquarter data center. We can have, and here is our DNS center. Right, if I go to these end devices, we have our network controller here. We can have our network controller in the branch. We can have our network controller somewhere in the data center. Doesn't matter, wherever you want. But there is a network controller that we have connected somewhere in our maybe data center or the headquarter. Let's say this is data center, and here we have our DNS center controller connected. So all these devices are going to be managed via this particular DNS center appliance. So from the design point of view, these are the physical devices that we are going to use. These all are the physical devices that we are going to use And all these devices will have their own set of rules and responsibilities. So a typical traditional network would look like this. Typical traditional network will have, let's say, for example, 3 or 2 layer from the architectural point of view. This is the access layer, this is the distribution layer, this is the core layer. And core layer devices are connected to our routers. And these routers are connecting us to the known destinations outside the SDA and unknown destinations outside the SDA. Unknown to reach to the unknown destinations, I might want to send my entire traffic to the firewall, and from the firewall, the traffic will exit towards the internet. Right? This is unknown destination. This is what we are referring to as internet. Right? So this is from the design point of view. This is how we have. This is how we are going to design. And do not forget about our ICE. We also need to have identity services engine somewhere. So let me do one thing. Let me add a generic device, and I'm going to call it our ICE, identity service engine. So let me, for the representation purpose, because I don't have any identity services engine in this packet tracer software, I'm going to use, let's say, for example, a server here that is going to be represented as the identity services engine or the ICE, or I can, you can choose any, it doesn't matter. It is just for the representation purpose. So this is WLC, this is ICE. Again, you can deploy this ICE in somewhere in the data center, headquarter. All you need is the reachability. All that you should have is the reachability from the identity services engine to the devices and the data center. Does not matter that if you have the ICE on the branch or you have the ICE on the data center or the headquarter. It does not. This everything that we have talked about is the physical layer. Everything that we have talked about so far is the physical layer. Physical layer is basically, physical layer is going to have these set of devices, these set of physical devices that we can add and connect together to create our physical infrastructure. And now all these devices have to be compatible with the DNS center. That is the main point. All these devices that we are going to add in our infrastructure have to be compatible with the DNS center. If you want these devices to be managed via DNS center, these devices have to be compatible with the DNS. Right? So next we will see how can we make sure that these devices are compatible, these physical devices are compatible to the DNS center. You don't need to memorize, first of all. You do not need to memorize like what devices are compatible with DNS center, what devices are not. Because all you need to do is to just to go to a website to find out if your existing infrastructure devices are going to be compatible with the DNS center or not. So all the devices that we are going to use, at our physical layer, all these from the device point of view, all these switches, all these routers that you see here in this diagram, even the wireless LAN controller, the access point, the identity services engine, everything that you see here in this diagram has to be compatible with the DNS center so that you can actually manage these devices from one centralized point, right? From this DNS center. These devices that we have here, these devices, these switches, if I talk about these switches that we have here, these routers that we have here, these devices that are compatible with the DNS center, what makes it compatible with the DNS center is a hardware chip that is installed on these devices. So devices that we are going to use in our SDA has to be from the compatibility list. They need a specific application, a specific integrated circuit so that we can define the rules on those devices and they participate in the SDA fabric based on its role. And that chip is called UADP, Unified Access Data Plane. Some older version switch platforms such as 3650, 3850, they also had this earlier implementation of UADP, Unified Access Data Plane hardware. It is present on these devices, 3650, 3850. That is why these devices are compatible for our SDA. Modern day switches, they come with the UADP switch, but so that they are compatible. But the old switches that we have in our infrastructure, such as 3650, 3850, they have to have, they also had that UADP chip, earlier version of the UADP chip. That is why they are compatible with the SDA. So devices to be used in the SDA network has to be from the compatibility list. They need a specific chip and a specific circuit, application specific integrated circuit, so that we can define the roles on the devices and they behave based on the defined role in the SDA fabric. And that chip is what we called as UADP, Unified Access Data Plane. This is a hardware that need to be present onto the device so that the SDA deployment is supported on the devices. Modern day switches come with that UADP chip, but the old switch platforms such as 3650, 3850, they also have that UADP chip, so they are compatible in the SDA fabric for certain role. Now, these switch platforms that we have here, 3650, 3850, they have that UADP chip, but they are still, they will not be considered as compatible for the SDA deployment if they don't have a supported software installed on that. This UADP chip, this Unified Access Data Plane, this UADP chip is programmable, right? So Cisco can basically push a firmware upgrade onto these switches, and they can add the support of things such as VXLAN, which is a key component in our SDA deployment. So just because you have a 3650, 3850 series switch platform that comes with a UADP chip, it is not going to make this compatible with the SDA. You also need to make sure that the appropriate software is running on these devices so that it is considered compatible in the SDA environment. These chips that we are talking about, this UADP chip is programmable so that Cisco can push a firmware upgrade on these switches so that they can add the support of functionalities such as VXLAN. Earlier days, these switches, these CAT 3650, 3850 did not have the support of the VXLAN, but then Cisco pushed a firmware upgrade for these Catalyst 3650, 3850 series switch platform. They programmed UADP, they programmed this Unified Access Data Plane to support the VXLAN functionality. And that is why these Catalyst 3650, 3850 series switches are now compatible in our SDA deployment. Modern day network is all about Catalyst 9000 series switches. In a modern day SDA deployment, in a greenfield deployment, where everything you are going to start completely fresh, we will mostly see Catalyst 9000 series switch platform. All these Catalyst 2950, 3750, 3850, all these series switch platforms, they have been replaced with Catalyst 9000 series switches. So in a modern day campus area network, you will see Catalyst 9000 series switches being used in the network, and they have the updated version of the UADP, and they run IOS-XE. IOS-XE. They do not run on iOS. iOS, like the operating system that we have on the router switches, it has more like versions. It has more like flavors, if I say. We have iOS, we have IOS-XE, we have IOS-XR. Like, you know, we have different types of operating system. Based on our requirement, we can have either iOS, we can have IOS-XE, or we can have IOS-XR on the routers and switches. The Catalyst 9000 series switch platform, the Catalyst 9K series switches that we are going to use in our modern day campus area network, they come with IOS-XE. They come with IOS-XE. IOS-XE. IOS-XE is a version of iOS that runs on Linux, right? So more like iOS runs as an image on that Linux platform, and side by side on this iOS image, we can also run some other supported applications within that Linux architecture. We'll study that in a moment. Point is, IOS-XE architecture, when we talk about the IOS-XE architecture, the base architecture is based on Linux. So base of this IOS-XE architecture is on Linux, and iOS runs just as an application on that Linux box, on that IOS-XE device. On the device, on the switch, this iOS is running as an application on this Linux-based environment, and side by side we can also load other applications that can run on the same box. We do not need to have those applications running on a separate device, separate box. We'll talk about that in a moment. what is this Linux architecture, what is this IOS-XE architecture, we'll talk about that. But the point is, we need to have, first of all, we need to have the unified access data plane. You need to have the UADP chip on the devices for the devices to be compatible. And we need to have a proper software version, proper IOS-XE version on these devices so that these devices are compatible to be added in the SDA network. And you don't need to memorize what devices are compatible, what devices are not compatible, because all you need to do is to just search SDA compatibility metrics. You just need to search SDA compatibility metrics. Just search the SDA compatibility metrics right here. Just search the SDA compatibility metrics. Just click on the first link. It will open this type of web page. And right from here, you can choose either you are going to deploy the SDA completely fresh or you are going to upgrade it. You are going to upgrade the DNS center from one to other. You can check the compatibility metrics based on the same. So let's go for the fresh deployment. Let's go for the new deployment. What is the release of the DNS center that you are going to deploy? So this is the, currently we have like 2.3.5.0, but the recommended release is 2.3.3.6 based on the testing and implementation. 2.3.3.6 is the recommended release of the DNS center. So we have 1.3, 1.3.2, 3, 4, 5, 6, 7, then 1.3.1, 2, 3, 1, 3, 4, whatever it is. So we have version 1, version 2, like this is like the release number 2.3.3.6 is the recommended release for the SDA deployment. Right, so SDA, let's say for example, we are going to deploy this SDA version. This is our DNS center version in our infrastructure. So the DNS center that we have installed in our infrastructure, it is running the 2.3.3.6 version of operating system. So if I click on this, now we have to select the role. These are like, okay, do you want to check what ICE version is compatible with this DNS center version? Just click on ICE and click on submit. And you will see that if you want to go for this 2.3.3.6 version of the DNS center, what ICE version has to be there? ICE version recommended release is 3.1 patch 5, but these are all the versions that are supported. These are all the versions that are supported. So let's say, for example, you have version 2.6, but you don't have a proper patch installed. It will just not work. It will not work. It will just not work. You have to have the ICE with the appropriate patch installed for this to be compatible with the DNS center. And this is this release. If you go for the other releases, such as 2.3.5.0, if you go for the other release, click on submit button, you might see the support of the identity service engine might get changed as well. Some ICE versions might not be compatible with this version of the DNS center. So you have to be careful. What version of that? Let's say, for example, you are currently running this version, right? And they say that, okay, now you need to migrate to version 2.3.5.0. So do you need to migrate the ICE as well? Just go to this compatibility matrix, click on this, click on submit, and see what ICE version you are running. Is it compatible with this release or not? If it is compatible, then you are good to go. But if it is not compatible, you also need to consider upgrading the ICE version before you proceed with the upgradation of the DNS center. Right? This you have to check. Now, similar to that, what wireless devices are supported? Click on this wireless device, click on here. So these are all the wireless devices that are supported. Catalyst 9800 series wireless LAN controller running on the IOS-XE version 17.6.4 as the recommended release, and other supported releases are this one. If you have any other release, then this one, it will just not work. It will not be considered as compatible. And these are the device models for Catalyst 9800 series switches that Catalyst 9800 series wireless LAN controller that are supported. This is the device series. This is the device model, recommended release of the software, and the supported software releases. Then Catalyst 9800 series embedded wireless on Catalyst 9300, 94, 9500 series switches. We have this concept of embedded WLC. In the embedded WLC, embedded wireless LAN controller, the wireless LAN controller functionalities are embedded on the Catalyst switch. So like I said, these Catalyst switches run a version of the iOS that is what we call as iOS-XE. iOS-XE is the iOS version that more like runs as an application in a Linux box. In a Linux-based box, iOS is running as an application. We can not only run that, but we can also run some other supported applications as well, such as we can run the WLC functionalities. We can run the wireless LAN controller functionality right on the same box where we have like Catalyst switching functionality, where we have the switching functionality. So Catalyst 9300, 94, 9500 series switch platform, they also support this embedded wireless. These are the models. This is the iOS release, and these are the supported releases. These are the access point, Wi-Fi 6 enabled access point. These are the models that are supported. This is Wi-Fi 6 access point. These are Wi-Fi 6 access point. Old Wave 1, Wave 2 access points are also supported like this. 802.11 AC Wave 2 access point, AeroNet series, 1800, 2800, 3800, running on AirOS or iOS-XE. This is supported actually. This is supported. If your access point is running AirOS or running the iOS-XE, it is going to be supported. It is going to be considered compatible with the DNA center. Old access points such as Wave 1 access point, like old access point, 802.11, Wave 1 access points, AeroNet 1700 series, 2700 series, 3700 series running on AirOS or iOS-XE version 17.3 is going to be supported. Industrial heavy duty series access point, Catalyst IW heavy duty series access point are supported as well. Industrial wireless 3702 series access point. These are the wireless LAN controller that are supported. Like all these things are supported. So find out the compatibility. There's also like we can also have this virtualized like 9800 series. This is supported embedded access point. This is supported, so everything else will work properly, right? So this is for the 2.3.3.6. Similarly, you can go for 2.3.3.3, whatever version you are running. In short, whatever version you are running, you need to find out the version. You need to check the supported devices, and then you are going to implement these in your. Then you are going to either you might need to purchase the new APs, new WLCs, or you can just upgrade the operating system to iOS-XE or the supported releases, and you can take the benefit of the SDA right there. No need to purchase a new hardware for the same. Right? Similar to that, if you are going to go for upgrade, click on this upgrade button. You are upgrading from what release? 2.3.3.6 release to 2.3.5 release. ICE. Let's check about the ICE. Click on submit button. So these are the supported releases on the 2.3.5.0. Make sure that you have these ICE releases on your device. It is supported, and this is recommended. You want to check about the, let's say, for example, wireless. Click on this, and these are the wireless platforms that are supported. So you can also refer if you are going to migrate from one version of the DNS center to the other version of the DNS center. Do we need to change the operating system? Do we need to change the hardware devices in our infrastructure or not? So that you can check from the upgrade tab. You can go for the fresh deployment of the DNS center, or when you are upgrading the DNS center version from one to another. Right? So all these devices have, and all these devices must have some version of the Unified Access Data Plane, UADP, and then this is going to make your device compatible. This is what is going to make your device compatible with the DNS center. Again, you don't need to memorize it. Just search the SDA compatibility metrics, and you can check the compatibility right from the website. No need to memorize what device is supported in the SDA. Right? Questions? Any doubt? Anyone? Let me know. Any question? Anyone? Yes, Sandesh. Let me know.
Yes, sir. So in this device, does ASIC also present there, or is the UADP the replacement of ASIC chip?
UADP is the ASIC actually.
Oh,
UADP is the application specific integrated circuit that they have. And
okay.
CPU, of course, is going to be there as a dedicated device. In switches, most of the things are implemented on a dedicated chip, which is what we refer to as ASIC, application specific integrated circuit. Alongside that, we also have that the CPU and everything we also have, right? So CPU is going to be there, and alongside that, we are going to have this. We should have this a specific ASIC, which is what we refer to as UADP, so that we can support this SDA deployment.
So sometime it also called as network processor, UADP.
Not exactly. Route processor and all those things are there, but I'm really not sure anyone has referred to this as network processor yet.
Okay.
Typically, they called it ASIC. Typically, they just called it ASIC. And in terms of this specific ASIC, we called it UADP. UADP version 2.0 is the one, I think that is the latest one. UADP 2.0, in some versions, we have that UADP mini. Older versions have the earlier implementation of the UADP. UADP is just a dedicated hardware chip that we have on the devices to support the SDA functionality if we want to use that.
So it is a programmable chip, right?
Yes, it is a programmable chip where the Cisco, for example, can push the firmware upgrades to enable certain functionalities on that particular platform.
Okay, thank you, sir.
Right. So when you place the order of the device, of course, they are going to tell you that, okay, this is going to come with this UADP, this is going to come with this UADP version, and you can find it out based on the same. Just like, in modern day, we have these laptops coming with this TPM module version 2.0 has to be there for Windows 11 and all. Similar to that, if your laptop, for example, does not have that TPM module, TPM 2.0, it will just not be able to compatible. It will not be able to run Windows 11, for example. Similar to that, we need to have this as well. UADP 3.0 is there. I think UADP 3.0 is the latest one. 2.0 was earlier. UADP 3.0 is also there in the Catalyst switch platforms. Right. So find out the compatibility. If you want to study more about UADP, you can refer to this link. You can just search UADP, and this is a documentation that they have given about the UADP. What is Unified Access Data Plane? UADP 2.0 Mini, which used to. I will drop the link in the chat. You guys can copy it for your reference. Right. I have dropped the link in the chat just in case if you want to read it, you can copy the link from the chat actually. Right. So you can study about this UADP, which is an application specific integrated circuit that comes on these specific switch platforms. So earlier Catalyst switches, they also had this earlier version of the UADP. Now we have seen multiple variants of UADP such as 1.0, 1.1, 2.0, now 3.0. UADP 2.0 Mini was there in Catalyst 9200 series switches supporting only one core up to 100 gig of bandwidth, how many TCAM entries, buffers, and all. UADP 2.0, UADP 2.0 XL, UADP 3.0. So they have added the support of overall, they have added like support of more bandwidth, more buffer memory, more bandwidth when you do the stacking and everything. So they have just added more functionality in there. So earlier versions has UADP 1.0, then came 1.1, 2.0 Mini, introduced in 9200 series switch platform. 9300 has 2.0 XL, then 3.9500 series switch platforms come with UADP version 3.0. Again, no need to go in very much detail. Just study in basic what is this UADP and all. Just the basic. Basically, it is a chip that has to be present on the device, which is programmable. so that we can support the functionalities such as VXLAN. Otherwise, your SDA fabric will not be functional. Now, what is this IOS-XE? IOS-XE again is iOS running on Linux. Means like typically we used to have iOS. Typically, we used to have like iOS running on the routers and switches. Typically, we used to have these router switches in our network, traditional routers and switches in the network, where we used to install the operating system, and those operating systems, enable the functionalities of those routers and switches. So IOS-XE, if you talk about IOS-XE, IOS-XE is capable of containerized application, like for example, KVM, kernel virtual machine, Linux-based container. Basically, on the IOS-XE, the base of the IOS-XE is the Linux-based. So the IOS-XE operating system, IOS-XE is an operating system where iOS runs as an application in a containerized box, if I say. So IOS-XE is capable of containerized application, and they run them on the network device alongside with the iOS. So in the IOS-XE, we are running iOS. We have full-fledged iOS support. Alongside that, we can run the hosted applications as well. In the traditional iOS, we had these feature components. We had the infrastructure hardware. We have the management interface. We have the modules. We have the kernel. This was in the traditional operating system. These functionalities, all these functionalities are there in the IOS-XE, but this runs as an application on this IOS-XE box. Alongside with that, we can also run some hosted applications there, such as, for example, Wireshark. We have like with the releases of different versions of the IOS-XE, you will notice that we can run a lot of Linux-based containerized application in a virtualized environment inside the same box. So this switch is not only running the iOS, but it is also running some other containerized application, such as, for example, Wireshark or some other management applications as well. And they can communicate to each other. When you study SD-WAN, you study when we talk about, for an example, in SD-WAN, we have a router. Those routers are also running. Let's say we have a CSR router, cloud service router. We have an IOS-XE router. We have an IOS-XE router, let's say in SD-WAN. So what does it mean? It means that we have iOS running as an application on that box, on that router, and we can also run some other containerized application. Containerized applications such as, for example, Wireshark, or just in case if we have covered the SD-WAN part, we can also run some security application. We can download a security application image from Cisco website, and we can host that image right on this box. We do not need to have a different hardware for the same. This security application, let's say, for example, UTD engine image, Unified Threat Defense, UTD engine image, I can download and I can run on the same box. So that every traffic that is received first is inspected via that UTD engine, and then it is sent out of the device. I can do that. Cannot do that in the iOS. But in IOS-XE, it is allowed. The way they have developed this IOS-XE and they install it on the hardware devices such as routers and switches, it allows not only iOS to run, but it allows us to run other containerized applications as well, such as this security application image, such as the Wireshark and some other images as well. And they can also communicate to each other. They can communicate like they can communicate to each other as well. We can enable programmability in this itself. We can enable programmability in the same box itself, so that this device can be controlled via some APIs and everything. A lot of things are there in the IOS-XE. So we say that IOS-XE is a version of the operating system that runs on the device as an application. IOS-XE is the version of the operating system, version of this iOS that we have on our routers and switches that runs as an application onto the box, runs as an application onto the routers or the switches. IOS-XE is capable of containerized application running on kernel virtual machine or Linux-based container, and they run them, and these containerized application, they run alongside the iOS on the same box. We don't need to have different boxes, hardware devices. We don't need to have the hardware devices and connect them together like that. We don't need to do that. These service containers are the applications that can be hosted directly on the IOS-XE routing platforms. We have our full-fledged iOS functionality. We have this iOS daemon running the full-fledged iOS functionality, and we can also have some Linux-based container where we can run other applications as well. So it would, from the user point of view, it would look like that we are just accessing an iOS. We are just accessing an operating system. It would look like the same. It will look and feel like the same. It will look like that we are just accessing the operating system. However, in reality, no doubt you are accessing the operating system, but we can also run some other containerized application. Just like, for example, I said that utility engine image for security. No need to have a dedicated firewall. No need to have a dedicated IPS IDS. No need to have a dedicated, appliance for the security if you have a IOS-XE box, IOS-XE router onto the device, onto the branch. We can just, I'm not saying that you will get full-fledged functional, you will get everything that a traditional IPS can do. I'm not saying that. I'm saying that you can enforce basic security right on the box instead of having a dedicated appliance for the same. The level of security that you can enforce, of course, is going to vary. The level of control that we are going to have is going to vary. Of course, you have a dedicated device, dedicated firewall to do some sort of filtering, and you are just running firewall functions as a software onto a containerized application. Of course, there is going to be some differences. But at least we are not going to, if I have a small branch, I just need to do some basic filtering. No need to, I want to add some basic, I want to enforce some basic security. No need to configure, no need to purchase and install a new firewall there, IPS there, nothing. Just download this security application image from the Cisco website, that utility engine image, run it on the IOS-XE device itself, and you can enforce the security right there. You will study this in SD-WAN. In SD-WAN security. Similar to that, in our switches, also we have the same functionality. The switches that we have in our SDA, they run IOS-XE. Switches that we have in our software-defined access, they run the IOS-XE. They are also capable of running. They are also capable of running containerized application alongside the iOS. Right? So we have purchased the devices. What devices? We have purchased some Catalyst 9000 series switches. 92, 93, 94, 95, 9600 series devices. Or we have some old switch platforms such as Catalyst 3000, 3650, 3850, 4500 series, 65, 68 series number devices. We have compatible hardware routers as well, ASR 1000, ISR 4000 series routers. We have purchased our Catalyst 9800 series switch platform with embedded wireless LAN controller functionality. Or maybe we have a dedicated fabric-enabled WLC. We have purchased dedicated access point, like Wave 1 access point 1700, 2700, 2800, Wave 2 access point accordingly, we have purchased. We have purchased like fabric access point, like wave 1, wave 2 access points we have purchased. And let's say we have purchased all the necessary devices, and all these devices are compatible with the DNS center. And we have designed our network in this fashion. This is how we have connected all those devices together in our design, in our network design. Now, DNS center and ICE are also physical devices that we have to install in our SDA fabric. These can be said part of both physical layer and the controller layer. Of course, DNS center is a controller and ICE is a controller as well. WLC is also a controller as well. So DNS center and ICE, they are also the physical devices. DNS center is a physical appliance that you have to purchase and install. ICE comes in both fashion. ICE you can install in a virtualized environment such as ESXi, or we can have a physical hardware for the same as well. Right? We'll study that in ICE. So these DNS center and ICE can be put in both like physical layer and the controller layer. One more thing, it is just for our understanding, right? It's nothing like in SDA. This is the physical layer. This is that. This is just for our understanding that we can divide our SDA software-defined access network infrastructure into these 4 layers, physical layers and all. So the physical layer is basically the layer that consists of physical devices. Physical devices can not only be switches, routers, WLC access point, but it will also include DNS center and ICE. Right? So ICE can be both like a physical appliance, right? Or ICE can be a virtual appliance that can run in a virtualized environment such as ESXi. So ICE can run in both physical and virtual environment. There are dedicated server SNS, or we can run in virtualized environments such as ESXi. We'll discuss that in ICE section. Now, once we have purchased the devices, once we have connected these devices, once we have made sure the reachability between these devices, now we have to set the roles on the devices. We have to set the roles on these devices. Every device in the SDA fabric will be given certain role. Every device in the SDA fabric will be given certain role. And there could be the devices that do not even support the SDA. For example, these devices. These devices don't even support the SDA. In fact, they are not even Cisco devices. They are not even Cisco devices. These devices do not even support the SDA. These devices that we have, they do not even support the SDA, let's say. Right? These devices, they do not even support the SDA deployment. And in fact, they are not even the Cisco devices. We can say that as these are not even Cisco devices. ACIE is the ACIE and EPIC and all those things you have to study from the data center point of view. This is ACIE EPIC is the controller for the data center. DNS center is for the enterprise network, typically. If you want to manage the spine leaf topology, you have to have your ACIE infrastructure managed by the EPIC, application policy infrastructure controller, and DNS center is for the enterprise network. DCNM, you have to find out in the DC, might be something in the DC specific track, but DNS center is for the enterprise network. DNS center is a repurposed EPIC EM that you are going to use to manage your enterprise devices. Not going to manage the Nexus series switch platforms or anything. Some Nexus series switches are compatible, but for the Nexus series switch platforms that we use in our data center environment, EPIC controller is used there. DC management system that we have, DCNM and ACIE EPIC, that is for the data center. For our enterprise network, we have this DNS center. So these devices that we have, these are not even SDA devices. They cannot run these. This is 3750 series switch platform. This doesn't even support the VXLAN and list functionality. No. In fact, this is not even the Cisco switch. These are not even the Cisco switches. Fine. These devices are called intermediate nodes. These devices that we have, these are called intermediate nodes. Intermediate nodes that we have, these provides connectivity. These devices provide connectivity between the fabric nodes, but they are not part of the fabric itself. These devices right here, these devices. These devices are part of the underlay network. These are responsible to provide the connectivity between our SDA devices, but they are not part of the SDA fabric itself. They are responsible for forwarding the traffic in the underlay network, but they are not part of the SDA fabric overlay network itself. They might or might not even be the Cisco devices. All they need to do is to have the routing capabilities so that they can route the packet from one to another location, so that the traffic can be forwarded in the underlay network. No special hardware needed on these devices, such as UADP chip, nothing. No need of these special hardware chip on these devices. So these devices that we have connected in our SDA deployment, which is not even compatible with our SDA, which might not even be the Cisco devices, these are called intermediate nodes. Intermediate nodes are those devices that are going to receive the traffic, forward it, receive the traffic, forward it, receive the traffic, forward it, not being actively part of the SDA fabric itself. They might not even be the Cisco devices. They are not being managed by our DNS center. They are not the Cisco devices. So these devices are what we are going to refer to as the intermediate nodes. Apart from these devices, we have some special devices as well. Apart from these devices, we also have some special devices in our SDA deployment as well. And those devices are called basically extended nodes. Those devices are called extended nodes. Extended nodes are those special devices that are built for non-carpeted environment. Cisco has created some devices, some special devices called extended nodes to connect to non-carpeted environment, non-carpeted workspaces. What is this non-carpeted workspace? Non-carpeted environment are those that are hostile to the switches, such as warehouses, plant farms, and the other, where the temperatures or the dust or anything might damage the typical switches that we use in our enterprise network. So for the non-carpeted environment are those environments that are hostile to the switches, such as warehouses, plant farms, and the other devices. So to extend the software-defined access functionality to the non-carpeted environments, such as warehouses, such as plant farms, and the other environments, an extended node is going to connect to the fabric edge, and the fabric edge node is going to be managed by the DNS center. Means right here, we are going to connect an extended node. We are going to connect an extended node. This is typically again, this is a switch that is going to connect to our edge device. This is our edge node, and this edge node is being managed via this DNA center. To extend the SDA to non-carpeted environment, an extended node is going to connect to the fabric edge, and fabric edge node is going to be managed by the DNS center. These extended nodes itself are not compatible with the SDA, and they cannot run protocols such as VXLAN. These switches, these extended nodes, we can actually configure. These extended node we can deploy right here. We don't have any extended node here in the packet tracer, but let me do one thing. Let me put this switch here. This is I'm going to call as extended node, right? And I'm going to connect it with our device here. This is going towards our non-carpeted environment, such as a farmhouse, such as a warehouse, such as some other industrial place where that is not well suited for the traditional or the normal switches. Right? So extended nodes are those special purpose switches that they have designed for these non-carpeted environment, that non-carpeted environment that are hostile to our normal switches. Remember that these extended nodes itself are not compatible with the SDA, and they cannot run protocols such as VXLAN. They connect these extended nodes, they connect to the edge device, and this edge device is being managed via the DNS center. So whatever policies and everything we want to apply, we want to push, we can push those policies right to this switch, and this switch is going to implement the policy for these extended nodes. Right? Here. For enhanced security and segmentation, consider using policy extended node. Like we also have policy extended node because scalable group enforcement can be done on those devices. Instead of using normal extended node, we can use policy extended node. In the policy extended node on these devices, we can push the scalable group information to enforce security, for enhanced security and segmentation. Scalability, consider using policy extended node because the scalable group and enforcement can be done on these devices. And we have these switches called industrial Ethernet switches. We have these Catalyst digital building CDB series switches. We have Catalyst 3650 CX PoE switches that are categorized as the extended node and policy extended nodes. Again, these are just switches. Again, these are just switches that we have. These are just switches that we have built specifically for our hostile environment or our non-carpeted environment. You can refer to the data sheet of these switches. You can search all switch products, and you can get the information right from there. You can get the information from there. Here. Here, you can just search all switch products. It will, open this link, all switch products, and here you can just scroll down. Here, where is that? Yeah, industrial Ethernet switches. Just click on that, and these are the industrial Ethernet switches that you can run, that you can have in the network. Right? So you can just, you want to get the detailed information about them, you can just click on that and you can see this is how it looks like. These can work as the industrial Ethernet switches. These can work in those carpeted, non-carpeted environments such as factories, such as other locations. Yes, sir, Preet. Yes.
Okay, so these IE switches which we are talking about, so these are, I mean, so they are not a part of the fabric, right? So they no VXLAN, no routed config, just a plain L2 switches we can configure.
Yes.
So the configuration on these switches, can they be like pushed by the DNAP, or it has to be, we need to do it manually only, directly on the CLI?
Manually.
So
these switches are not part of the SDA design. Like they are not part of the SDA fabric. So you might have the capability to configure these switches manually on these devices. You might need to do some configurations of the VLAN and everything manually, but they are not going to be managed by the DNS center.
Okay, not even for the assurance part, right? Nothing, just not even for the monitoring. It will be never a part of.
We can always do basic things. We can always do about all, even though, for example, a 3050 series switch, right? See, SNMP is still going to be supported, right? SNMP protocols such as SNMP, syslog, and everything is still going to be supported. So we will get some degree of control. We can, for example, even for a typical 3750 series switch platform, even though that is not compatible with our SDA, but yes, we can do certain level of monitoring from there.
Okay.
So like when it comes to creating the fabric by configuring the device roles and everything, that is not allowed on these switches. But certain level of monitoring we can still do.
Okay. I mean, I was just comparing, like, so just suppose these are just L2 and we want to just push VLANs only, just few VLANs we want to configure it. So earlier, like we used to have Cisco Prime and all, right, where we used to do some basic config, we could have pushed it. So is it possible by DNAC, like we can just push some VLANs or some basic things on this switch by the DNAC?
Not exactly. You get like you can, for example, on the DNS center, from the DNS center itself, you can open, for example, the command prompt, and you can use certain commands to do some configuration. But in short, no. you have, like, if the device is not compatible with the DNS center, there are very good chances that you have to go on those devices one by one and do the configurations manually.
Okay. Okay. And we connect it with a fabric edge just on the trunk port, simple trunk link. We just connect it.
Yes. If you have multiple VLANs, you can consider it as a trunk. If you have a single VLAN access port, that thing is going to remain exactly the same. That concept of switching is going to remain exactly the same.
Okay, got it.
Right. We also have like CDB series switches. I'm not sure do we have here or not. But we also have like digital building series switches as well that are also considered here. Cisco Catalyst digital building series switches. Right. We have these series switches as well that are considered as extended nodes in our SDA deployment. Again, they are not compatible with the DNS center. They can connect in our building. They can connect with our Fabric Edge node, and we can push the configurations and everything on the Fabric Edge node. And these are not directly going to interact with our DNS center. Right. So these are what we call CDB, Cisco Catalyst digital building series switches. Right. So these industrial Ethernet switches, Catalyst digital building 3650 CXP switches, these all are going to be considered as like extended nodes. Okay. So now we have our switches that are compatible with the SDA. We have some devices that are not compatible with the SDA, such as these intermediate nodes. We have some devices. That are actually, if I say, that are built for non-carpeted environment. Right. So we have those devices as well. For example, we have those devices as well in the network. And we have basically built the network based on the same. We have built our network based on the same. We have created a topology and we have built our network based on the same. Okay. Now the rules that we can set on these devices. Okay, you have built this network like that. We have our devices here. We have we are going to refer to these, let's say, for example, access layer devices. Here we are going to refer to these as distribution layer devices. Here these are core layer devices. Some fabric as edge switches and all. We have some switches that are connected at the edge of our network. Right. And we have our ICE, we have our WLC, we have our DNS center, everything is there. We have connected all these devices all together. Now, we need to set the roles on these devices. We need to set the roles on the devices. There are 4 roles that you can set on the devices. Total 4 roles there are that we can set on the devices. One role is called Fabric Edge node. Second role is called Control Plane node. Third role is called Border node. And fourth role is for the wireless controller, Fabric wireless controller, which is what we are going to say Fabric enabled WLC. Right? So there are 4 roles. Fabric Edge node. Fabric Edge node are those devices in your SDA deployment, SDA design, that provide connectivity for wired endpoints and the access point. Means from whatever switch, we connect our wired user and our access point so that we can connect our wireless devices. These devices are referred to as Fabric Edge node. So all the devices that connects to the endpoint or the access point, we have to set the role. We have to set the role as Fabric Edge node there. Fabric Edge node provides connectivity for wired endpoint and the access point for the SDA fabric, and they are responsible to detect that a device is connected and register that information that a device is connected somewhere in the network. They are responsible for registration. They are responsible for registering the EID. EID means endpoint ID, which is basically just the IP address of the device or the MAC address device that joins the network. They are responsible to register that a particular device A is connected to me somewhere in the network. And they are responsible to encapsulate and decapsulate the data when traffic is being sent in the SDA fabric and sent out of the SDA fabric. So when the traffic is sent towards the devices, they will perform the decapsulation. When the traffic is sent in the fabric, they will perform the encapsulation. Right? So Fabric Edge nodes. In our design, what devices are the Fabric Edge node? These devices are going to be the Fabric Edge node. These devices are going to be the Fabric Edge node. These devices connect to the wired endpoints and the access point to facilitate the wireless user. So anytime any device comes here, let's say for example, a device is connected here. Let's say a device gets connected here. This device is responsible. This Fabric Edge node is responsible. This Fabric Edge node is responsible to register this information that a device is connected. A device with this IP and MAC is connected to me. That information it is going to register somewhere in the network. There is going to be a device in your network that is going to hold a database, that is going to build a database of endpoint ID and its respective switch, which in SDA term we call RLOC. RLOC means routing locator. Basically, IP or MAC of the device is going to be registered with RLOC. RLOC basically means switch IP address. This IP, this MAC is connected on 1.1.1.1. This information somewhere in your network is going to be maintained by some device. So whenever any endpoint is connected, in the network, this Fabric Edge node is going to register that this endpoint is connected to me somewhere in the network. This registration is called endpoint ID to RLOC mapping. What is endpoint ID? Endpoint ID is the ID of the endpoint that is just connected into the fabric, and this is basically the IP address or the MAC address of the device, and RLOC is the IP address of the switch. Here we have an IP address configured on the switch that is 1.1.1.1. So it is just another way of saying that A is connected to 1.1.1. This information is going to be maintained somewhere in our network, and that somewhere in our network is going to be known as control plane node. Yes, the control plane node is the device in your network fabric. It is the device in the SDA fabric that is going to build a database about the endpoint ID and their respective RLOC. That this endpoint is connected to this RLOC, this endpoint is connected to this RLOC, and this endpoint is connected to this RLOC. This information is going to be maintained in this device called control plane node. Control plane node provides a mapping system that manages the endpoint to device mapping. This endpoint is connected to this switch. This endpoint connected to this switch. This endpoint connected to this switch. That information is actually maintained on the control plane. They are an essential component in the SDA fabric, because if you don't have that database, your encapsulation, your data plane will not work. If you do not have this information somewhere in the network, if you do not have this mapping somewhere in the network, your data plane will not work. These fabric edge node, let's say, for example, now if I want to send the traffic from A to B, so traffic arrives onto this fabric edge node. When the traffic has to go to this device, first of all, this device, this fabric edge node needs to know. This fabric edge node needs to know where is B. So this fabric edge node is going to ask the control plane node, where is B? Control plane node will say, okay, you want to go to B, go to 5.5.5.5. B is at 5.5.5.5. So now this fabric edge node is going to encapsulate all the data with the help of protocol called VXLAN, and it will send it towards 5.5.5.5 after performing the proper encapsulation. After performing a proper encapsulation, it will send the data over this VXLAN tunnel, if I say, from one edge node to other edge. So when the fabric edge node sends the data, it will perform encapsulation. When it is received on this device, this is going to perform decapsulation, and it will remove that extra information and send the data towards the device. Yes, like how this fabric edge node will learn about the EID whenever this device sends some data, because these devices will send some data whenever they connect their cell phone onto the nodes. Whenever the data is sent onto this device is going to learn the MAC address of it, and then it is going to register that information to the fabric control plane node. It is going to learn the IP address of it, and it is going to maintain that information to the fabric edge node. So yes, with the help of the MAC learning process and the IP learning process, it will know about that. So the fabric edge node is responsible to perform encapsulation when the data is being sent in the SDA fabric, and the fabric edge node is responsible to perform the decapsulation when the traffic is being sent towards the end device. That we will talk about. We will see like how, like let's say, for example, I want to go from A to B, and this switch has no idea how to go to B. This switch is going to ask the control plane node how to go to B. This control plane node is going to respond that if you want to go to B, you need to go to 5.5.5. And that information is now going to be kept in a cache memory, so that for further communication from A to B, I'm not going to disturb my control plane again and again. But that is going to have some timer associated with it. After that time period, the entry will flush and you will have to ask again. But yes, it will not do the queries again and again to the control plane node. That we will discuss as well. How this will happen, that we will discuss as well. How the roaming will be handled, that we will discuss as well. It is a little bit a complicated task. We will talk about that in our next class, because obviously we don't have that much time today, but we will discuss that. How the roaming will be handled if the user has moved. Roaming is handled in the SDA fabric appropriately as well, without any problem. You will know how the roaming is going to be. But yeah, that there will not be any problem, even though the user has roamed. User has moved from one point to the another point. Right. So the fabric edge node is responsible. The fabric edge node is responsible to fabric edge node is basically responsible to encapsulate, decapsulate the traffic that goes in and out of the SDA fabric. This is where our end users are connected. This is where the access points are connected. Access points are going to build the VXLAN tunnel to this fabric edge node, so that they can offload all the traffic, and the traffic can go respectively towards the other devices. We will discuss that in the wireless section. Then we have fabric border node. These devices right here, these devices are referred to as fabric border node. Devices that connect our SDA fabric outside the SDA fabric to either known or unknown network. Right? So fabric border node provides the connectivity to the external network for the SDA fabric. They are the border of your SDA fabric, and they are meeting point between your fabric network and the outside network. This right here is the boundary of your SDA infrastructure. Here. So this switch is referred to as border node. That is going to connect you to the known destinations outside the SDA fabric, and unknown destinations outside the SDA fabric. Based on that, we are going to call it internal border node or external border node or anywhere border node. We will discuss that in a border node functionality. Just to give you the idea, border nodes are those devices that connect your SDA fabric to outside the SDA fabric, such as data center, headquarter, or unknown destinations such as internet. So these devices, these switches are going to be set as the border node. The role on these switches we have to set as the border node. And finally, the wireless LAN controller provides the connectivity for the wireless endpoint to the Cisco SDA fabric and management of the fabric-enabled access point. So this right here is the wireless LAN controller that we have in our SDA fabric. It is also going to be connected to our DNS center. It is responsible to register all the access points or manage all the access point, do some client registrations and everything. Whenever the client comes here, this access point is going to inform the WLC that the client has joined the network. WLC is going to push that information to the DNS center so that in the assurance, you will be able to see that what device is connected to what access point and all. So that part is basically handled by this fabric-enabled wireless LAN controller. We call this fabric WLC. We call this fabric-enabled WLC actually, because these WLCs are capable of connecting to the DNS center and maintain the responsibilities of managing all the access points and the end users. So the fabric-enabled WLC provides the connectivity for the wireless endpoints to the SDA fabric, and they manage the fabric-enabled access points. So Cisco has just announced end of life for Cisco Prime Infrastructure on 31st March 2023, means 2-3 days back. So Cisco Prime Infrastructure, which was primarily product for our campus network management, now it is going to be replaced by the DNS Center anyway. So end of life has been announced for the Prime Infrastructure as well. So DNS Center is going to be managing now all these devices, and these are the rules that we are going to set on these devices from the DNS Center itself. We don't need to do any configuration about the same. We don't need to do any configuration when we have to set this role or this role or this role or this role. We don't need to do any configuration. We just go to our DNS Center. There is just a tab. Let me show you. There is just a tab. You just have to enable this tab, and that's it. You don't need to set any, you don't need to actually configure anything for the same. You just need to enable this by just clicking on that, and it will enable the edge role functionality. Whatever commands are needed, DNS Center is going to push those commands to that device so that it becomes the edge node, border node, control plane node, or even the fabric-enabled wireless LAN controller, wherever it is. Right? We'll see that. Just need to enable it right like that, and all the commands are going to be pushed there. No need to do it manually. Yes.
Okay. So like you were just saying that now the Prime will be over, right? That it will be end of life and all. So just wanted to check, maybe, let's suppose we have like Cisco switches and all. Okay. Maybe not SD enabled switches, but maybe the other switches, or maybe the same series, but we don't want to run it in an SDA mode or in a fabric mode, just a traditional way when we used to configure, right? Core distribution access layer, L2 and gateways on L3 switch. So if that kind of fabric we want to just build it, is it something that on the DNS Center also provides that option? That is one point. And even though if the DNS Center does not provide that, we manually configure the switches, but still we can just manage it on the DNS Center, right? Like from a monitoring and assurance perspective.
Yes. Just don't set the rules. Set the rules. Like just add the devices, build your topology, build your sites, build your everything. Just don't set the rule. Do not create the fabric. That's it. Okay. Don't set these rules. It will be like, it will keep operating in a traditional network. No problem.
Okay.
So yes, we can manage. Again, like I said, even though the devices are not compatible with the DNS center, we still have some degree of control. I will show you that. When we do the lab, I will show you that we have some Catalyst 3750 series switch that we will be using in our topology. I can discover that switch, but that switch is not compatible with our DNS center. So we will not be able to do a lot of things actually from the configuration point of view, but still that switch will keep operating as it is.
Okay, but then that will not be plug and play, right? I mean, we just need to do some manual config so that reachability is there between the NAC and the switch, and then we can just discover it on SNMP.
Yes, you can do some sort of monitoring from the DNS center, but if you want to go for the configurations and everything, yes, you need to access the switch via console or telnet SSH, whatever it is, and then you need to do the configurations all by yourself.
Okay. Got it.
Yeah. So if you want to set the rules on the devices, all you need to do is to just check, just click on this and it will set the rule. No need to do any configurations on there. It basically DNS center will push whatever configurations are needed to be pushed to make the device act as the edge node, water node, or the control plane. So in our topology, these are fabric edge node, these are intermediate node, these are border node, and we can have a switch acting as the control plane node, or we can have a router acting as a control plane node. Just in case if I don't want to have the responsibilities of the border node and the control plane node on the same device, no problem at all. We can have a dedicated router or a dedicated switch that is acting as the control plane node. One or two we can have, no problem. Or we can set, we will talk about that, but we can set both the responsibilities of the control plane and border node on the same device as well. Completely your choice, whatever suits you. But yes, we can have both the functionalities on the same device, or we can have the functionalities on the dedicated, for example, router. So this is our control plane node. This is our control plane node. This is control plane node. This is intermediate node. This is the border node. This is the edge node. And this is overall SDA. This is the fabric enabled access point. This is fabric enabled WLC. This is our ICE. This is our DNS center. Everything is reachable to everyone. Not exactly. We will talk about that in the border node and the control plane node. It is recommended that you have at least two of them, two control plane node, two border node, so that we have some sort of redundancy. Other than that, it is completely your choice of design, which one you actually go. We can set the border priority as well on the border switches so that one is preferred over another. And when one goes down, then another one will be used. So we can set that thing as well. That is also possible. But from the control plane node point of view, they recommend that you have at least two of them so that if one goes down, at least the other one is functional. And we will have two of them in our network as well. So just the overview. This was just the overview of all the roles that we can have on the devices. Now we will talk about in detail about all these devices. What is fabric edge node? What is the endpoint ID, RLOC mapping and all? What are the devices compatible with this? How to enable it? This now in detail we will talk about in our next class.